இது யாருப்பா? Sister has joined. No? Very good morning, sister. Amy, shall we start? Sister, good morning.
Yes,
I
ma'am.
welcome all the participants for this inaugural function. Amy will start.
A dream written down with a date becomes a goal. A goal broken down into steps
Good
become a plan.
morning.
A plan backed up by action makes your dreams come true. Good morning. It's my pleasure to be the moderator for today's Atal sponsored online FDP. I am Emima,
Shall
Assistant
we
Professor in Computer
start?
Science, Holy Cross College. On behalf of the PG Department of Computer Science, Holy Cross College, Trichy, I heartily welcome you to the online
Time is
5 days Atal sponsored faculty development program on integrated
I
data
think
analytics, the
only
tools and
47
application across industry
have
verticals.
joined.
A smile suffices to assure you that you are welcome. Your presence makes us very happy. Here's a hearty welcome, big and warm enough to encompass you. It's my pleasure to extend a cheerful welcome to all of you. With immense joy, I render a cordial welcome to Reverend Dr. Sister Krishna Bridget, Principal, Holy Cross College, all the expert speakers and participants of Faculty Development Program. I extend a warm welcome to Dr. H.M. Leena, Director of MCA and Head Department of Computer Science, Dr. Rosalind Selvarani, Assistant Professor and FTP Coordinator, and all the computer science faculty members. A hearty welcome to all of you. Prayer is the surge of the heart. It is a simple look turned toward heaven. It is a raising of one's mind and heart to God. Prayer is the song of the heart. It enlarges the heart until it's capable of containing God's gift of Himself. Let us start this day aright, invoking the presence of God amidst us. I request Dr. Sheila and Miss Edel, Assistant Professors of Computer Science, to lead us in prayer.
Savior. Lord, there is none like you. All of my days, I want to pray the wonders of your mighty love. My comfort, my shelter, tower of refuge and strength. Let every breath, all that I have, never cease to worship you. Come on, shout to the Lord. Oh yeah. Power and majesty. Praise to the King. Mountains bow down and the seas will roar at the sound of your name. I sing for joy of your hand. Forever I love you, forever I'll stand. Nothing compares to the promise I have in you. Sing it again. Shout to the Lord. Oh, shout to the Lord. Let us sing power and majesty. Praise to the King. Mountains bow down and the seas will roar at the sound of your name. I sing for joy. Yes, forever. I love you, forever I'll stand. Nothing compares to the promise I have in you. Oh, nothing compares. Nothing compares to the promise I have in you. Nothing compares. Nothing compares to the promise I have in you.
The reading from the Holy Bible, Psalm 145, verses 1 to 7, 9 and 21. I will exalt you, my God the King. I will praise your name forever and ever. Every day I will praise you and exalt your name forever and ever. Great is the Lord and most worthy of praise. His greatness no one can fathom. One generation will commend your works to another. They will tell of your mighty acts. They will speak of the glorious splendor of your majesty, and I will meditate on your wonderful works. They will tell of the power of your awesome works, and I will proclaim your great deeds. They will celebrate your abundant goodness and joyfully sing of your righteousness. The Lord is good to all. He has compassion on all he has made. My mouth will speak in praise of the Lord. Let every creature praise his holy name forever and ever. Amen.
Prayer. Let everything that has breath praise the Lord. Praise the Lord. Psalm 150, verse 6. Every good and perfect gift is from above, coming down from the Father of lights. Merciful, omnipotent Father, as the new day dawns, we joyfully come before you and worship you. You are awesome and worthy of all the praise. Father, we stand in your presence today. Allow your Holy Spirit to saturate our hearts and souls. Enlighten our minds and let your love be upon us. Give us a wise and understanding heart, a heart that readily discerns your will. You are our shepherd, the one who always guides us. Empower us with your guidance and guide us every single moment of the 5-day faculty development program with your rich grace. Bless this day, this blank page newly turned. May its story, once written, bring glory to your name. The grace that you give is amazing. In your infinite generosity, please grant us continued graces and blessings. In Jesus' name, amen.
Thank you, professors, for leading us in prayer and invoking God's divine presence amidst us. Welcome every morning with a smile. Look on the new day as another special gift from your Creator, another golden opportunity to complete what you were unable to finish yesterday. May I request Dr. Rosalind Selvarani, Assistant Professor and FTP Coordinator, to deliver the welcome address.
This is a day that the Lord has made. We will rejoice and be glad in it. A very pleasant morning to one and all virtually connected with us today. It is a very good privilege to welcome you all for the 5-day online faculty development program on integrated data analytics, the tools and applications across industry verticals, sponsored by AICTE Learning and uh, Teaching and Learning Academy. In today's scenario, it is clear that there is an exponential growth of the realization of digitized entities, connected devices, and microservices whose when these interact purposefully, there is a massive amount of multi-structured data getting generated, collected, and cleansed in order to extract the actionable insights out of the data heaps. Business houses and service providers have plenty of data at this disposal, which need to be processed, managed, and analyzed to get the desirable insights. Data analytics plays a key role in streaming valuable insights from the data. Keeping this in mind, a faculty development program is planned on the above theme to enable the educational and research scholar to get in touch with the trends and tools so that they inspire and equip the next generation to fit to the industrial expectations. With the short note, I would like to welcome the chief guest of the Insight inaugural function. The fragrance of flowers spread only in the direction of the wind, but the goodness of a person spreads in all directions. Amidst us, we have such an inspiring personality, Reverend Dr. Sister Christina Bridget, our beloved principal, the dynamic and innovative leader of Holy Cross College Autonomous Trichy 2. It is she who motivated us to apply for the actual FDP, and without her encouragement, this FDP would not have been possible. Dr. Sister Christina Bridget is a leader with a vision and aims at imparting quality and holistic education to the student community. As a principal of the college, she envisions expanding opportunities for the young minds and focuses in mobilizing resources to enhance the campus life and learning. Sister has completed her PG course in Commerce in the year 1986, MPhil in 1995, PGDCA in 1997, MBA in 2013, and PhD in 2014. She is a passionate teacher of commerce who is a student-centric and innovative in teaching methodologies encouraging students to maximize their professional by increasing their social skills such as team spirit, leadership, and communication. As a tech-savvy person, she facilitates learning using multimedia and virtual techniques and handles smart classes. Sister trains in leadership skills and women empowerment modules. She is also a certified learning and development professional endorsed by Training Qualifications United Kingdom. She has proficient knowledge in human resource management, organizational behavior, marketing and total quality management, and the sister has core competencies in visionary leadership style, excellent decision making capacity, flexibility, team player, lateral thinking, outcome oriented person, committed to student and faculty empowerment. She has held various positions as vice principals to more than 5 years, head of the Department of Commerce from 2009 onwards, and as a principal of Holy Cross College from 2017 onwards. She has acted as a subject expert in Board of Studies and Academic Council for many colleges and advisory committee for college with potential for excellence. She has 30 years of teaching experience and vast experiences in research too. Under her meritorious guidance, 20 members have been awarded MPhil and 2 members have been awarded PhD and 6 are currently pursuing PhD. She has published more than 15 papers in well-reputed international journals and completed 3 major projects. A grant amount of 2,200 USD was sanctioned for the minor research project on entrepreneurial training on spirulina and microgreens cultivation for undergraduate students in 2017 to 2018. Sister is a doctoral committee member and Viva was examiner in various colleges in and around Trichy. Sister has organized a number of UGC-sponsored national conferences and has also chaired academic sessions at national conferences. She has initiated the HEC alumni chapter in Dubai in 2017, Malaysia and Singapore in 2018. As a resource person, she has conducted many sessions at various topics such as whole person education, emerging trends in commerce and trade, gender sensitization, women and academic leadership, and so on. To add to her credit, she has received IMC Ramakrishna Bajaj National Quality Award, and in the year 2020, she has received Women of Wonder Award for innovative practices and academic excellence. Under her noble guidance and leadership in 2020, our college has achieved A++ grade in 4th cycle with a CGPA score of 3.75 on a scale 4.0 scale by now. It is a great opportunity for all of us to have such an eminent and versatile person to inaugurate online ATL faculty development program. I extend a warm and genial welcome to you, sister. I also extend a cordial welcome to all the resource persons who have joined with us in this inaugural function. I feel much delighted to extend a friendly welcome to all the participants from the various states of India, and I am sure we are going to have a 14 fruitful session ahead. Last but not the least, I welcome the head and all the faculty members of PG Department of Computer Science, Holy Cross College, Trichy. Once again, I welcome one and all connected with us through this Google Meet. Thank you.
Thank you for the cordial welcome, ma'am. Reverend Dr. Sister Christina Bridget, our beloved principal, is known for her wonderful dynamic administration and high innovative achievements of this institution. She is an effective listener, problem solver, great visionary, and a very dedicated personality. We, the Holy Crossians, are immensely proud of her efficient leadership. We are very honored and privileged to have her with us this day. May I invite our beloved sister principal to render the inaugural address.
Good morning to all of you. Today, new normal has become online webinars. and it is a day in and day out. And thanks to the pandemic, because due to that, we are able to attend in a n number of meetings through this webinar. And one, I think one such meeting will be this webinar, which have been arranged by our department staff of computer science. I congratulate the Department of Computer Science for taking this effort of conducting the FTP program, and especially to Dr. Rosalind, who has been the coordinator for this program. And I also thank the AICTE for giving us the permission to granting us the permission to conduct this FTP, and of course sponsoring the amount so that this webinar has been made free for everyone to participate. And we are living in a very uncertain world. We don't know what will happen tomorrow. So with that in mind, this topic was taken into consideration, especially technology has become the man of the match. And we know this integrated paper on tools and techniques for the computer science will be very useful for all the participants. And this is a golden opportunity which have been given for you all to participate. And we have very good resource persons from various fields who are connected with this tools and techniques, who will be enhancing your skills so that you take away home a good amount of knowledge which will be helpful for you to for your future. So I wish you all the best and a happy learning. Thank you.
Thank you, sister.
Thank you, dear sister, for the inspirational address. Gratitude can transform common days into thanksgiving, turn routine jobs into joy, and change ordinary opportunities into blessings. May I request Ms. Baby Nirmala, Assistant Professor of Computer Science, to deliver the vote of thanks.
Give thanks to the Lord with all your heart. Gratitude without expressing is similar to wrapping a gift and not giving it. I deem it a great honor and privilege to propose the vote of thanks on this auspicious day. Sometimes I just look up and say, I know that it was you, God. Thanks a lot. First and foremost, I thank the Lord Almighty for His showers of blessings, grace, and wisdom throughout the preparation of this virtual faculty development program. I take this opportunity to thank Sister Niranjana Antony, Secretary of our college, for her ever-loving support and prayers. From the bottom of my heart, I thank our beloved Sister Principal, Christina Bridget, the visionary who always sees beyond and leaves a mark wherever she goes. God always places the right people in authority at the right time. Sister, you always accept challenges and does things extraordinarily. Sister, we are proud to be the Holy Crossians under your able leadership. Thank you, sister, for your inspirational talk. Next, my sincere thanks to the FPP coordinator, Dr. Rosalind Selvarani, for her striving and constant efforts in organizing this event during this new normal days. The teacher, who is indeed wise, does not bid you to enter the house of their wisdom, but rather leads you to the soul of your mind. I take this opportunity in thanking the resource persons and all the teaching fraternity from all the colleges and institutes who chisel and shape the lives of the students. Last but not the least, my thanks to our HOD and faculty members for their constant efforts in making this program a successful one. Thank you for your presence. Without you, this function wouldn't be complete. Every day, there is something to learn. Yes, even during this new normal days. Happy learning. Once again, I thank one and all gathered online.
Thank you, ma'am. Rosalind, ma'am, shall we start the first session?
Just a minute, huh? With a short break, we can start the first session.
Yes, yes, ma'am. Yes.
Good morning, Peter, sir. Shall we start?
Yeah, madam.
Emima, you can just introduce. Resource person is already connected with this. We can start the first session.
Yes, yes, ma'am. As we about to begin, a few reminders and instructions for the participants. Kindly mute your audio and turn off your video. If you have any queries, post it in the chat box. The queries will be answered by the speaker at the end of each session. Each day, each session, attendance link will be posted towards the end of each session. Participants are requested to fill the attendance form and submit before the next session begins. Moving right along, it is now my pleasure to invite Ms. Baby Nirmala, Assistant Professor of Computer Science, to introduce the speaker of this session.
This is the day that the Lord has made. We will rejoice and be glad in it. Yes, placing my feet right here with head held high, I am much happy and honored in welcoming the August gathering for this online faculty development program. God raises the lowly and the humble and seat them with the kings and the lords. Amidst us, we have such an inspiring personality, Dr. Peduru Raj Chellaya, a lifetime researcher, technical writer, and a welcoming speaker. Working as a chief architect at Reliance Geo Platforms Limited, Bangalore, previously worked in IBM Global Cloud Center of Excellence, Wipro Consulting Services, and Robert Bosch Corporate Research. He has more than 20 years of IT industry experience and 8 years of research experience. Finished the CSIR sponsored PhD degree at Anna University, Chennai, and continued with the UGC sponsored postdoctoral research in the Department of Computer Science and Automation, Indian Institute of Science, Bangalore. Thereafter, he was granted a couple of international research fellowships, JSPS and JST, to work as research scientist for 3.5 years in two leading Japanese universities. He focuses on some of the emerging technologies such as Internet of Things, optimization of artificial intelligence models, thick, fast and streaming analytics, blockchain, edge and serverless computing, reliability engineering, microservices architecture, event-driven architecture, 5G, etc. One tree can start a forest, one bird can frame a goal, one candle can wipe out darkness. A true leader has a confidence to stand also. He is a man of virtue in helping many emerging scholars. Though he is in high position, you can reach him at ease for any scholarly help. He has many websites and blogs to ignite the students, researchers, and technical learners. He is the author of many research papers in reputed international journals. He edited many books, and they are followed as key to researchers and textbooks and in the universities and colleges. The teacher, who is indeed wise, does not bid you to enter the house of their wisdom, but rather leads to the soul of your mind. I welcome all the teaching fraternity gathered here. I take this opportunity in welcoming all of you, as well as we know a smile is an universal welcome. Once again, with a smile from my heart through my lips, I welcome you all.
Thank you, ma'am. Now, without further ado, let me hand over the session to Dr. Pedro Raj on the topic of integrated data analytics. Please, sir.
Yeah. So I'm Peter. I work for Reliance Geo Platforms Limited, Bangalore. So today I would like to talk about data analytics. That is a great part and parcel of data science. So data science is very interesting topic, and today there are millions of job opportunities waiting for data scientists. Those who have experience and expertise on data science technologies and tools, they can easily get job not only in India but in other parts of the world. So data science is emerging as a very top end domain. I think there are a couple of more speakers who are going to dig deep into this data science aspect. They will talk more, but I will restrict myself to data analytics. Okay. So let me open my. Okay, I think some problem in sharing my PPT because I am using Apple laptop. It has some issue with this Google Meet. So what I will do, I will um, share my PPT to you. Someone from your end can show that.
Sir, sorry to interrupt.
Yeah.
But I think if the moderator can stop sharing the screen, you can probably share yours.
Yemima,
Yes, ma'am.
stop sharing your screen, pa, so that the resource person can share his own screen.
Yeah, so I have shared that PPT to Madam Roslyn, Madam,
Sure,
through
sir,
an
sure.
email.
I didn't
Okay,
share.
so because I could not share the PPT in my laptop. There is some issue. It is asking for some special permission and all. Okay, so when you get the email, please share it at your end. So I will talk about that. So,
Sure, sir. You send me
typi-
your PPT to my personal ID so that I can share it with the
yeah, I already
participants.
sent it, madam. Already I
Yes,
sent
sir.
it.
Thank you,
Yeah.
sir. Thank you, sir.
Yeah. So thank you for giving me an opportunity. I thank the college principal and this FDP coordinator and other faculty members in computer science department, to all the other people who are in this session. Okay. So as I told you, I work for Reliance Geo Platforms Limited. We are extensively working on some of the digital transformation technologies. I have quoted around 13, 14 digital transformation technologies in my slide. When the slide opens, you can see them. Okay, so the you can get those details from Gartner report also. So I have identified some of the top 10 or top 15 technologies that are from various sources. So we in our company, we are extensively using these technologies to bring forth a digital transformation application, digital life applications. Okay, so we are developing a variety of digital applications that are being built using these technologies. So the first one is without doubt artificial intelligence, the Internet of Things, then blockchain, then microservices architecture, then event-driven architecture, 5G communication, okay, then digital twins. So there are so many application technologies and tools that are emerging that will help you to develop digital transformation, because in at least in the industry, from a software engineer to CTO, chief technology officer, everybody use the word digital transformation. So we are extensively accustomed to this term, digital transformation. Almost all the prominent technologies are being categorized as digital transformation technologies, because we are entering into the digital era. So you might have heard about so many other terms related to digital era, like digital application, digital economy, okay, digital coin. So these are some of the terms that are extensively leveraged or used across the globe, and the digital era is in our hand. So we need to be equipped with various kinds of digital technologies and tools in order to be right and relevant to our people, our constituents, our customers, our consumers, our clients. Okay, so one of the technologies, prominent technologies, as I told you in the beginning, it is nothing but data science. In the data science, there are several. 1 second, I will open my. Okay, so yeah. So in the third slide, you can find around 14 digital transformation technologies: artificial intelligence, integrated analytics, blockchain, IoT, enterprise mobility, digital twins, cloud native computing, serverless computing, fog computing. Okay, so these computing models are very popular nowadays. You will hear more about that in the days to come. Okay, so we have been talking about cloud computing. You might have heard a lot about cloud computing through various seminars and online sessions, but slowly we are moving towards cloud native computing. That is the future of the cloud journey. Okay, then serverless computing is another interesting phenomenon, and that is more or less automation. Automation means today, if you develop an application, what you have to do, you have to deploy that application in a laptop or in a server machine or in an enterprise server or in a cloud server. Correct? For that, there are so many people like administrators, system administrator, application administrator, storage administrator, cloud administrator. They take your application and they will deploy in cloud servers, so that people from various parts of the world can go through these applications. Correct? That's the purpose of putting your application in a cloud server. Anybody from any any parts of the world can use that application for their own purposes for a fee. Okay, it may be free or it may be for a small fee. Okay, so why we need to take the applications to cloud? So that people from any part of the world can use it for their own purposes. Okay, so and now the cloud native computing is very popular. It is a kind of new software engineering. How we have been developing software using multiple technologies like object oriented programming, component oriented programming, correct, aspect oriented programming, agent oriented programming. Even we have been well versed with service oriented programming. Now we are going towards microservices oriented architecture. So cloud native is a combination of multiple technologies, including microservices, containerization, container orchestration, DevOps. So these are some of the technologies that are very popular for cloud native computing, serverless computing. As I told you, for serverless computing, there is no need of human intervention or interpretation or involvement for deploying your application. A developer can himself or herself can easily deploy the application in a cloud server. All the manual activities are getting automated through serverless computing. So that means serverless means that doesn't mean there is no server. There are server machines in order to deploy your applications. But what do you mean by serverless computing? That means there is no human operator or human administrator to put forward your application in a cloud environment, in a server machine. Okay, automatically all these technologies are combining well to put your application directly in serverless computing. So we can go on like edge computing, that's very popular. Okay, microservices architecture is the very basic architecture for designing, developing, deploying your application. Event driven architecture is another interesting architecture that helps a lot. Okay, so typically
Excuse
I
me, sir.
don't go by PPTs, but
Excuse
today
me,
I
sir.
have decided to be little different, so I am reading from the PPT directly.
Excuse
Okay,
me, sir.
so
Excuse me,
yeah,
sir.
yeah.
So PPT got ready.
Okay, you can
Shall
show it, madam.
yes, we are sharing. Dear
Yeah.
participants, kindly pin Dr. Arokya Shagaya Sheila. Arokya Sahaya Sheila. Dear participant, kindly pin Arokya Sahaya Sheila. Thank you, sir.
Yeah. So yeah, so I talked about some of the prominent technologies that are in the industry, and slowly that will percolate to the academia also. You will hear more about these technologies in the days to come. Okay, so now we talked about these technologies, digital transformation technologies. These digital transformation technologies, um, okay, one second, resulting in such a phenomenon. Okay, I changed it to 2022. I used to put 2020, but because of the pandemic situation, all the forecast, all the predictions when the average, that means it didn't happen as per the forecast given by all the market leaders like Gartner, Forrester, IDC, and the other market leaders. Okay, so I have changed it to 2022. So there will be millions of microservices, maybe next year, by next year. There will be billions of connected devices. There will be trillions of digitized entities. Okay, so I'm in the slide number 5. So these are all the implications of digital transformation technologies. When you are using your digital transformation technologies purposefully, you will this will result to such a phenomenon, such a scenario. Okay, so this is what we could identify from the various reports. Okay, now when these software services, when these devices, when these digitized entities, when I say digitized entity, it is IoT devices. Okay, combine, talk to one another, interact with one another, collaborate with one another, what will happen? There will be lot of multi-structured or polystructured data. Massive amount of polystructured data will be generated. Okay, that is the result of having these many millions, billions, and trillions of entities. Okay, so I have given some. Go to fourth slide number 4. I have indicated. Where from the data comes. Okay, consumerization. That means we will have billions of devices. It can be your wearable devices, it can be your handheld devices, it can be your pocketable devices, it can be your portable devices, it can be your mobile devices, it can be your embedded devices, or it can be your consumer electronics, it can be your robots, drones, okay, or kitchen utilities, or medical instruments, or defense equipment, or manufacturing machineries, whatever it is. There are so many kinds of devices that are coming up that can be purpose specific as well as purpose agnostic. Okay, so that is the first reason why there will be huge amount of data. Okay, first reason is consumerization. People are extensively buying and using a variety of devices in their everyday lives. Okay, for their personal uses as well as for their professional uses. Okay, second thing is digital entities. All our common, casual, cheap things in our environments. It can be our home, it can be our hotel, or it can be our hospital, or it can be our offices, it can be our retail stores, whatever it is. There are different environments that are being filled up, stuffed with variety of digital entities. I have given that. Okay, so your window will become a digital entity, your table will become digital entity, your cart will become a digital entity. Okay, so there are processes, methodologies that are being produced for converting your ordinary entity into extraordinary entity, for converting your dump object into animated object, or your common object into cognitive object. So these are some of the technological innovations and disruptions that are being accomplished through digital transformation technology. So digitization, that's why I have indicated in the slide number 5, there will be trillions of digitized entity. All the common items that are there in our environment can be a digital entity. That means, what do you mean by digital entity? It can perceive, it can visualize, or it can communicate, it can do computation, it can respond, it can take decision, it can take some action. Okay, so for example, if you are coming from your office, you want to have a hot water, what you can do from your office itself, through your cell phone, you can switch on your geyser at your home. So when you are reaching at your home, the hot water is ready. So that sort of digital application, digital services will become very prevalent, prominent, in the days to come. Okay, so that's what I have indicated. So then there are cloud infrastructures, your server machine, your storage appliances, your networking solution, your firewall, your IPS, IDS, your switches, your routers. Okay, so many infrastructures are there in every cloud environment that are getting digitized, that are getting connected, that are getting cognitive. Okay, so then now all the things are getting connected with one another through various communication technologies, wireless communication like Wi-Fi and 4G, 5G, then wired communication is there. So all things are getting connected. So several years back, when I was doing my PhD, Nokia came into India. At that time, they put a advertisement in MG Road, Chennai, Nokia connecting people. But today, if you go to any software company, IBM or Geo, whatever it is, there you can find the word connecting everything everywhere. Okay, so all the things in our environments, in our location, in our places will get connected with one another in the vicinity as well as with the applications that are getting hosted in faraway cloud environments. Okay, so that is the thing. For example, I am working out of Bangalore office. When I go to my office, I will swipe my ID card in the door entrance, then only door will open so that I can enter into the office to start my official work. Okay, but what is happening when I swipe my card into the door reader capture all the details that are there in my ID card, and it will send to the application, KaiChar application or access control application that is getting hosted in cloud. Cloud is in Navi Mumbai, exactly 1,000 kilometers from Bangalore to Navi Mumbai. So the data has to travel all the way to Navi Mumbai Cloud Center. In the Cloud Center, we are running the KaiChar application, KaiChar databases. There, the details will be compared, matched, whether the ID card that is carrying that details is matching with the data that are already stored in the KaiChar database that is there in the cloud environment. Then if the data is found matching, if the data is found correct, then that application will send a message back to Bangalore saying that, okay, you can now open the door. Okay, then only I can enter into the office. Okay, so what I'm trying to tell is things are getting connected not only with the nearby things, but also faraway things. Okay, so that's what I would like to tell here. So I can go on like that. Those who are interested, how the various amount of data, various types of data are getting generated, are getting collected, are getting stored, are getting processed. Okay, so that you can visualize that. So things are getting connected, so connected things will always send a lot of data. So then I will skip some slides. Okay, so I will jump into the slide number 9. Okay, I am in slide number 9. So I have 1 more hour. So yes, 11 o'clock I have to go to an official meeting. So I will sharply finish at 11 o'clock. Okay. So the data implications of the digital era. So if you go to bank, you can see the word customer is the boss. Okay, but hereafter you will see the word data is the boss. Data is the strategic asset. Our chairman used the word data is the new fuel for the digital economy of our nation. Okay, so data are getting generated in massive quantities, large numbers. Okay, but unfortunately, due to various reasons, only 2% of the total amount of data that are getting generated every day across the globe are being analyzed, are being collected and analyzed. Okay, so data implications of the digital era. Okay, so sorry, my mother is cooking something. Okay, so okay, sorry. Yeah, so we have zillions of digital entities, and we have, as I told you, we have millions, billions, and trillions. Correct? So we have zillions of digital entities that correspond, connect, communicate, collaborate, correlate, and corroborate with one another. So that data getting generated is massive and multi-structured. So as I told you, when multiple things interact with one another, there will be a lot of data generation. Okay, for example, when you use your credit card, that credit card details getting transmitted to your bank, and it will go to your wallet, and it will go to your payment server also. So multiple interactions are happening when you initiate buying something through Amazon or Flipkart. Okay, so that's what indicated here. So multiple applications, multiple data sources correspond one another, and they will generate lot of useful data. Okay, so by the year 2025, this I got it from the internet. Okay, there will be 463 exabytes. Exabyte is 10 power 18 bytes. Okay, per day. That is the amount of data that is getting generated from 2025. Okay, another reason is another strategy is the data that is getting generated.
Sir, the voice is not coming clearly. Could you please request the moderator to stop sharing her screen? I think then we will get a better sound. Thank you.
Yeah, now it is audible. Yeah. Okay, so
It is audible, but not that clear. Now it's clear.
okay. Yeah. So anyway, you can go
Sir, it
through.
is audible, sir. You can proceed.
Yeah, anyway, you can go through my slides. So I have clearly written, articulated the point that I am talking, so you can easily understand. It is not that difficult to understand. So one strategy is the amount of data that are getting generated today is equivalent to the total amount of data that are getting generated in the last 50 years. That is the data explosion. Okay, so that is the data explosion. So you can visualize how much data is getting generated every day. Okay, so
Sorry, sir.
Tell me.
Sorry, sir, what you are teaching and PPT, both are not matching, sir. So I think you please share PPT and then. I think someone sharing PPT and you are speaking, so that is not matching.
Okay, so yeah, so I am on slide number. 1 second. Yeah. Okay, I will. 1 second.
Sir,
I'm in
actually,
slide.
that is saying the data implications of the digital era.
Yeah. I'm in slide number 9, madam. So you can show that. Okay, so the amount of data that is getting generated is
You
very
just say
huge.
next, sir. Sorry for the interruption, sir. As soon as you complete
next.
the first slide, you just say next so that we can proceed.
Okay. Yeah, so that is the amount of data that is getting generated. So data is a strategic asset. Data can be big, fast, and streaming data types. Okay, you all know about big data analytics. Okay, that means volume, velocity, veracity, viscosity, virtuosity, all are varying. When the amount of data is very big, then you will call it as big data. When the amount of data is reasonably less, you can call it as fast data. When the amount of data is very less, that is fast, but velocity is high, then it is called streaming data. Okay, so that's what I have indicated there. So batch data, so batch processing, real-time processing, and other processing are there. Okay, so you can go through that. Another 1 hour is there, so I will speed up the process. Okay, so this is the data implications. Madam, you go to slide number 11. I have skipped 10. Okay, so okay, what is data science? I am in slide number 11. What is data science? Data science is all about playing around with your data to extract some insight, some information, some knowledge, some cognition. Okay, that is the idea. Okay, so data science is the science of playing around with your data to extract, to emit out, to squeeze out a lot of insights, useful insights. Okay, so that is about data science. So data science is about extracting your knowledge out of data. Okay, there are several steps that are being associated with the data science. Okay, so yeah, first step is data collection, because there are multiple entities and elements that are generating lot of data, that are distributed, that are decentralized. One sensor may be in your home, and another sensor can be in another places. Okay, so there will be multiple data generating entities that are getting distributed across the globe, and we have to collect the data from different and disparate data sources, data locations. Okay, so that is the first process. Second one is data ingestion. Once you collect the data, now you have to ingest the data into the storage system or the processing system or the analytical system. Okay, there are several toolkits, automated toolkits, open source as well as commercial grade toolkits available for collecting your data as well as for ingesting your data into the target environment. Okay, third thing is data pre-processing or data preparation. What do you mean by data pre-processing? There will be the data that are coming from multiple sources will be in different data formats. There are different formats for data storage, data exchange, data representation, data persistence. Okay, so there are multiple data formats. So, but your target environment is accepting only one data format. What you have to do? Data translation. You have to translate from the original data format to the target format. Okay, so that is a kind of data preparation or data preparation. So some nice data will be there, maybe some columns will be empty, you have to fill it up. Okay, because otherwise the decision making system will give a wrong output, a wrong decision. Okay, so in order to avoid that, you have to do a lot of pre-processing on the data that you have collected from multiple sources. Okay, so that is data pre-processing stage. Then data storage, that is I will explain that when I talk about data analytics. So fifth one is data analytics. There are typically two data processing methods: traditional data processing, another one is artificial intelligence processing, AI processing. Okay, the final stage is knowledge visualization through dashboards and reporting solutions. So a data scientist has to have very deeper, broader knowledge on all these six things. Okay, they have to be compatible with the tools and technologies for data collection, data ingestion, data cleaning, data masking, data wrangling. Okay, then data storage, database management system, data lake, data warehouse, then data analytics. Once the data reaches the data storage databases or data warehouses, then you have to plunge into data analytics. There are so many data analytics platform, tools, accelerator, engines available. So you can use one of them. So finally, data visualization tools are reporting solutions or dashboards like Tableau. Then what else? Quick click view. Okay, Sisense, Microsoft BI server. So these are all some of the knowledge visualization toolkits that will generate lot of maps, charts, okay, graphs, okay, reports, all these things. So you are converting your data, raw data, into knowledge. Okay, so that is the process that is getting accomplished through data scientist. So data scientist mainly worries about how to convert the raw data into information and into knowledge. So that is the primary role of a data scientist. So as there are a couple of sessions already finalized for data science, I think today afternoon Professor Arogyam is talking about data science. So I will leave data science part to him. I will just focus on the fifth part, that is data analytics. Okay, so that is my main agenda for the next maybe 1 hour. I will strictly go by data analytics. Okay, so I will jump into next slide, 12th. Okay, different forms of data analytics. Okay, so several years back we were talking about only big data analytics. Then it came streaming data analytics or real-time analytics or fast data analytics. Okay, then IBM has introduced a new concept called cognitive computing. Then cognitive data analytics came into picture. In the recent past, we are extensively talking about artificial intelligence. Okay, so that is artificial intelligence based data processing. So these are all some of the analytical methods, methodologies, or mechanisms that are gaining prominence these days. Okay, so I have just focused on analytics part. All other parts you will hear more from other professors. I am okay. So I will talk about conventional analytics in the subsequent slides, and I will talk about the advanced and automated analytics. Then third one is I will talk about the infrastructure for doing data analytics. Okay. So before jumping into the next slide, I would like to tell one prominent difference between conventional analytics and advanced analytics or automated analytics. Okay, for the difference is this. For creating or for producing big data analytics application or fast data analytics or what else, streaming data analytics, you need two ingredients. One is you need data. Okay, without data you cannot do anything. Second, you need to write the logic also. You need to write the program also, maybe in Python, maybe in R, or maybe Scala, or maybe there are so many other programming languages through which you can write the data processing logic. So two ingredients are needed, data and logic. Okay, so these two are very, very important for doing the conventional analytics. So what are the two things you need? Data plus logic. Logic is program. Okay, you need to these two things for doing big data, streaming data, and real-time data analytics. Now, for doing automated analytics or cognitive data analytics, there is only one ingredient is sufficient. That is, you just give the data, you need not write the logic. There is no need for a developer to sit and write the program for doing advanced or automated analytics. Okay, herein I tell one story why it is automated analytics. Okay, so yeah, so there is this use case that is there in IBM website. Okay, so I used to tell this story everywhere because analytics is very important. You are generating lot of data. You should not throw any data out. You instead you have to meticulously, carefully collect all the data, store all the data, do the data crunching or do the data analytics, do the data processing or do the data investigation on that data in order to convert that data into information and information into knowledge. Okay, so but for cognitive data analytics, as I told you, there is no need for any programmer or any software engineer or developer to sit and write the program. Okay, for example, IBM has a cognitive analytics platform, IBM Watson Healthcare. Okay, so when I was with IBM, this IBM Watson was very, very popular, very, very popular. Okay, most of the manual activities can be easily surmounted or automated through this Watson software. For example, every day there are 121 research papers getting published on oncology, that is on cancer research across the globe. Okay, every day 121 research papers are published across the globe on cancer research alone. Okay, how many research papers a cancer doctor will go through every day? Maybe if he is a very vociferous reader, he will go through 1 or 2 research papers per day. Okay, that's all he would do. Okay, so now with that limited knowledge, with that very limited knowledge, the doctor is diagnosing cancer patients and he is recommending medication for cancer patients. Okay, now IBM Watson software is a software that is a cognitive software, that is artificial intelligence based software that was purchased by Manipal Cancer Hospital in Bangalore for several crores. Okay, so what is the advantage? This Watson software can go through 3 million pages per minute. How many pages? 3 million, 30 lakhs pages per minute. That means if you just give your blood data, data into this cognitive system, that is IBM Watson. IBM Watson will go through all the research papers that got published in the last 50 years within minutes, and it will tell that a cancer doctor saying that this is the medication you can recommend to this particular cancer patient. Okay, so that is the advantage of cognitive analytics. You are giving only the input data, that is blood data. Okay, there is a use case. One lady in Tokyo University, she was a cancer patient. She was getting treatment from cancer doctors in Tokyo University. Even after 6 months, there was no recovery. There was no improvement in that lady. Okay, so finally, Tokyo University people bought IBM Watson software, and that doctor again called that lady to the university hospital, okay, to do the recheck. So they get the fresh blood data. Okay, so then they used that IBM Watson software, and Watson software totally changed the medication, just opposite to the medication recommended by the human doctor. This Watson software totally changed the medication, and that lady started improving. Nowadays that lady is doing fine. Okay, so what I'm trying to tell is analytics is very important. Okay, analytics is very important, and that analytics here, in the era of cognitive era, everything is getting automated. There is no need for a software engineer to sit and write the application, to sit and write the logic for processing the data. But in the olden days, for big data analytics, for real-time analytics, for streaming and data analytics, developers have to write the logic, plus they have to get the data from multiple data sources. Okay, those who are working on data science or data analytics area, and they can easily identify the difference between these two concepts. So that's why I have given the title as advanced analytics for cognitive data analytics. For the conventional or traditional analytics is big data and real-time data analytics, streaming data analytics. Okay, another interesting phenomenon, interesting example I would say. So why analytics is very important? Why data has to be subjected to a variety of investigations to change the data into information and information into analytics, insights or information or knowledge. Okay, so another interesting thing is we have been calling the word big data analytics. I will throw more light on that in the subsequent slides. Okay, so the point is this: there is a story. Okay, not this is a story, this is a real time incident. Okay, so please listen carefully. Several years back, some 20 Israelites, okay, people from Israel, Tel Aviv, okay, they wanted to go to Spain, okay, for vacation. Okay, so one guy was waiting in the Spain airport for the arrival of these 20 Israelites. Okay, he was wandering inside the Spain airport for them to come. There was a bus waiting outside the airport. Now the flight from Tel Aviv reached Spain. These all the CCTV cameras that are there in the airport, Spain airport, are capturing the images of this person who is wandering inside the airport. So the people, 20 people came out. They entered into the bus that was waiting outside the airport, and this guy committed suicide in front of that bus. He killed himself, as well as he killed all the 20 Israelites. So this happened several years back. This is not a story. This is a real lifetime incident. Okay, what I'm trying to tell is, when this is CCTV cameras were capturing the image of the person who is wandering inside the airport, all the images were captured and stored in the image database. But what they have not done, have they done had they done that analytics on that image data, analytical system would have told that there is something mysterious with this guy. So please catch hold of him and interrogate him, so that disaster could have been avoided. Okay, so point is this: so not only collecting data, but also you got to do analytics on that data. Not only big data analytics, but also you got to do real-time analytics. What is the difference between big data analytics and real-time analytics? Big data analytics, you collect all the data, and in the night time, you will do casually the analytics on the data. But that is not the case with the real-time analytics. Whenever there is a data getting collected, immediately that data has to be crunched. Immediately the data has to be analyzed. That is real-time data analytics. Okay. So big data is you can do collect all the data during daytime, and when all the people goes out the bank, all the banking data gets subjected to a variety of investigation in the night time. Maybe at 12 o'clock in the night, by 3 o'clock early morning, the analytics would have been completed. Next day morning, when the manager comes to the bank, all the insights that were created out of the banking data, how many people applied for home loan, housing loan, car loan, personal loan, whatever it is, all the data gets crunched, and the manager will be in a position to take decisions based on the knowledge he has gained out of that analytical system. Okay, so I understood the big data analytics and real-time analytics. So you have to do the analytics immediately once the data comes in. You should not wait even for a single second, because if they have waited, that airport incident would have avoided. If the data analytics was completed immediately, then that airport incident could have been avoided. That is the point that I would like to insist here. Okay, so now we jump into the next slide, 13. Yeah, so this is the typical reference architecture. Okay, so at left side you have data sources. Okay, there are so many kinds of data sources: IoT devices, applications, okay, databases, data warehouses. So infrastructure, devices, so many things. They generate structured data, semi-structured data, fully unstructured data. So that is data sources. Now you have to do the ingestion. As I told you, there are several data ingestion tools like Flume, Scoop. Okay, ETL tools are there. ETL is extract, transform, and loading. Okay, otherwise ELT tool is there. Okay, there are messaging tools like Kafka. Then there are APIs, application programming interfaces, JDBC, ODBC. You might have heard about that. If you are connecting databases, then replication is there. Okay, so that is data integration or data ingestion. Then where the data gets stored, there are so many data storages, databases, data warehouses, then operational databases, data marts, data cubes. Okay, those so many things. Now when you have your data on databases or data warehouses, then you can apply analytical techniques, analytical algorithms, analytical methods to extract knowledge out of that voluminous data. Okay, so that is data analytics. Then data visualization, that is the last one. As I told you, you have dashboards, you have browsers, you have applications, you have mobile devices, you have microservices, so many things. Okay, so this is the overall reference architecture, macro level architecture for converting your data into knowledge. Okay, it goes through multiple phases, multiple systems, multiple applications in order to convert your data into data knowledge. Okay, so another interesting architecture for big data. Okay, so you can relate this architecture with the previous one. Here this is a technical architecture. I have indicated what are the technologies involved in this conversion of data into knowledge.
நீ சொல்றதெல்லாம் தான், பட் இவனோட அதெல்லாம் கற்றுக்கிட்டோம். பட் அதே நேரம் மொத்தமும் வந்து வர மாதிரி ஒரு இது அவனுக்கு சொல்றதெல்லாம் அதுல அப்படி குறிப்பிட்டே இல்லை.
ஓகே, yeah, so yeah, this is the BDA, big data analytics architecture. You can easily visualize that. So one side we have data sources, so data ingestion is happening through a variety of agents, Flume as well as Scoop or ETL. I explained that. Then it gets stored in HDFS, Hadoop, distributed file system. Okay, so this is that's why big data analytics. That's why I have given only file system. Then Spark or Hadoop or MapReduce or whatever it is. Okay, there are so many new open source technologies that can do big data analytics on the data that are getting stored in file system as well as databases. Okay, so that is on the right side you have visualization. Okay, so on the next one. Okay, so I have given some ingestion tools. Okay, Apache Plume, that is a tool that collect all the log data. Okay, log data means typically in the infrastructure side, in the cloud environment, we collect a lot of log data. Who is assessing which application, how many times they have assessed, whether the application is running perfectly okay, what is its performance, what is its health condition, whether it is scalable or whether it is adaptive. So many data can be collected out of your application. It can be your SAP application, it can be your knowledge management application or supply chain management application. So many things. So Apache Plume is an open source tool that collect and aggregate all kinds of log data. Okay, then similarly Nifi is also another interesting open source data ingestion tool that will help you to collect a lot of data and it will route it. It will do some transformation. As I told you in the beginning, some data has to be translated into different data formats so that data can be accommodated in the target environment. Okay, so many things. So similarly, Logstash is there, Goblin is there, okay, Scoop is there, okay. Then Kafka is a messaging system that helps to get streaming data. Okay, typically Kafka is for streaming data. All other data ingestion solutions are typically for big data. Okay, so that is the these are some of the popular data ingestion solutions. This you can use it in the beginning stage. So first data sources, then once you identified the data sources, then you have to worry about data ingestion solutions. Okay, so that is the second thing. Okay, what is the third thing? Now once if you use the data ingestion solution where you can put your data, there are so many data storage mechanisms. Physical storages are there, okay, file systems are there, databases are there. Databases, again, SQL databases, NoSQL databases, new SQL databases, distributed SQL databases. So many databases are there nowadays. Okay, we are extensively, for example, Facebook is an application that is using Apache Cassandra as the NoSQL database. Okay, similarly, BigQuery that is being used by Gmail or Google. Okay, so there are Twitter is using. I'm not sure which database, but it is using one of the NoSQL databases. So Twitter is using that. So most of the social media applications, social websites are using NoSQL databases. Okay, so still traditional applications like banking application, SAP applications are still using structured databases, that is SQL databases like Oracle, SQL Server, okay, PostgreSQL, MySQL databases. So based on the application, people are using different kinds of databases. It can be SQL databases, NoSQL databases. In some cases, for example, we are using in-memory databases, that is Redis database. Okay, that is in-memory. That is, instead of storing your data on disk, you can store your data on memory itself. That is in-memory databases. What is the advantage? Every time, whenever there is a need for some data, the processor will request the data from the disk. Suppose your processing machine is in Chennai, but if your storage is in Hyderabad, every time the data request has to travel all the way from Chennai to Hyderabad and come back. Okay, but that is not the case with the in-memory database. Wherever the processing machines are there, in that machines, the data gets stored in the memory itself. So in nanoseconds, the data can be fetched from the memory to the processor. Okay, that is the in-memory databases. So many databases are there. Okay, so these are all some of the popular databases. For example, if you have worked on Amazon Web Services, AWS, you might have used S3. S3 is an object database Therein, all kinds of data are being stored. That's S3 is a data lake also. It's an object storage. It can store up to terabytes, petabytes of data. Okay, that is the power of S3. Plus, Amazon uses so many other databases also. It is using SQL databases. It is using Dynamo. Dynamo is the NoSQL databases in Amazon. So similarly, so many other databases that are being utilized by multiple cloud environment service providers like AWS, Azure, Microsoft Azure, Google Cloud, IBM Cloud, Alibaba Cloud, Oracle Cloud. Okay, so many cloud centers are there across the world, and these cloud centers are using multiple databases. Okay, so the cloud data storage is very popular, and it is very cheaper also. That is the advantage of cloud storage. Instead, you have to buy your own cloud storage. You have to find a room for that to put that cloud storage appliance. Then you have to appoint a storage administrator to take care of that storage machine. Okay, so many things. Okay, so that is a difficult part. That means you have to invest heavily, then you have to maintain it. It will cost a lot of money. In order to avoid that, if you get S3 storage or any other database storage from Amazon or any other cloud service provider, you just pay for the usage. How many hours you are using that storage, you have to pay some peanut, maybe some $1 or $2 per month. Okay, so that is the advantage of cloud storage compared to on-premise, your own proprietary storage system at your own premises. Okay, so that is the so we talked about data sources, all kinds of devices, machines, sensors, applications, infrastructure. Okay, sales data, business data, sensor data, so many data sources. Then data ingestion, we saw that in the last slide. Then this is data storage mechanisms, where we can store your data. Once your data is stored, then you can go for processing or analytics. Okay, so that's what I have given. Apache Hadoop is very popular some maybe 10 years back. Nowadays there are advanced technologies that gives much more powerful performance. For example, there is a research paper that states that Apache Spark is 100 times faster than Apache Hadoop. Okay, so because Apache Spark is using in-memory computing, that means it stores recent data in memory, not in disk. Okay, but in Hadoop it is stored in disk. Okay, there is a difference. In Hadoop, MapReduce is the processing framework and HDFS is the storage framework. But in Spark, you can use Spark processing. You can use MapReduce processing also with the Spark, and instead of HDFS, you can use SQL databases also as far as Spark is concerned. Apache Spark is concerned. So Apache Storm is a distributed computer processing system that is mainly for streaming data, not for big data. Okay, Apache Storm is mainly for streaming data. Flink is also for streaming data. Okay, Apache Samsa is also for streaming data. Okay, that internally leverages Kafka. Kafka is the streaming storage, that is streaming data storage. Okay, so that is the architecture. So people who are comfortable with this streaming data analytics can easily visualize where from get the data, how to store it in Kafka, from Kafka how to take the data through topics. From the topics you can apply any one of these Samsa or Flink or Storm to do the crunching, to do the data processing. So that is the mechanism here. So we started with the data sources, data ingestion, data storage, then now data processing. The final one is visualization tools. Okay, so I explained that in the beginning. So these are some of the popular tools that will help you to visualize all the knowledge that you have acquired from the data processing frameworks. Okay, data processing tools will emit out a lot of insights. That insights can be visualized through these graphs, charts, maps. so that business executives can take the decision very quickly, very correctly, in timely fashion. Okay, so that is the advantage of this visualization platform. Okay, so now we enter into streaming analytics. I throw some light on that. So this is the architecture for streaming analytics. Okay, so typically streaming data, as I told you, data is continuously flowing. For example, you go to IoT data, that IoT sensor, that IoT sensor is fitting an oil rig. Okay, then oil rig is in faraway place. You cannot easily visit that place. Okay, it should be in the middle of the sea, or it will be in a faraway place, or unapproachable place also. So these IoT sensor collect a lot of data about what is going on in that environment, in that device. It continuously flows the data. So that is why it is called streaming data. So the difference between big data and streaming data is, big data is a delicate data, that is atomic data, that is what I can say, it has an end, it has a beginning and it has an end. Whereas for streaming data, it doesn't have any beginning, it doesn't have any end, it is continuously flowing, it is continuously puring. Okay, so that is the difference between streaming data, but the amount of data that is getting streamed is very less. Whereas for the big data, you collect all the data of the day, then you do the batching, that is aggregation or combination or collection or clubbing together all the data. Then the amount of data that has to be crunched through big data analytics platform is very high, very huge. Okay, but in the case of streaming data, the amount of data that is getting generated, that is getting transmitted, that is getting put it into this streaming data analytics platform is very less. But the difference is, it is a continuous data, it is continuously flowing. Okay, so that is the thing. So the broker, I told you, you can go for Kafka, or it can go for, there are so many brokers, I could not get it from my mind now. But there are so many brokers available for getting streaming data. Okay, for example, in Geo we have mygeo.com. That's an application. Okay, mygeo.com. Millions of users are coming to this mygeo.com application every minute. Millions of people, because 432 million people are using Geo phones every day. Okay, and apart from that, we have so many other devices, connected home devices, connected car devices, connected healthcare devices, connected utility devices, so many devices. So 1 billion plus devices are there in India alone for Geo. Okay, 1 billion plus devices. These devices are collecting a lot of data from Kanyakumari to Kashmir. Okay, so that's the streaming data. So we are using one appliance in the place of broker. What I'm trying to tell is, you see that broker in Kafka is the most popular broker in the planet Earth, but Kafka is a software. Whereas we went for a hardware appliance. It's a appliance. It's very expensive. We paid several crores to buy that hardware appliance. Why hardware appliance? Why not Kafka? Kafka is software, so the performance is not up to the mark. But Solace is the appliance that we have purchased from a Canadian company. That Solace can give high performance. It gives the high performance. It doesn't lose even a single data. Okay, it captures all the data that are coming up from multiple sources across India. Okay, so that is the but inside that appliance we are running Kafka kind of software. Okay, it's a JMS compliance software, Java messaging service. Okay, so when you are free, you can go to solace.com. You can understand more about this appliance. It's a hardware appliance. You can touch and feel. It is very expensive, but it is very high performing. Okay, that is the advantage of. So in the broker place, we are using hardware. Now from hardware, it will go to stream processor. Okay, so broker is a Kafka is a broker, Solace is a broker. Whereas what is stream processor? As I told you, it can be your Spark stream or Kafka streaming or Storm or Flink or Samsa. Okay, so there are so many open source stream processors available. Commercial grade stream processing processor also available. For example, IBM has Info Streams. That's a commercial grade stream processing system that is very costly. Okay, so there are open source as well as commercial grade stream processor. Then it will go to real time as well as gold data storage. Okay, so once you do stream processing, it will stored in a Redis database, or it can stored in Cassandra NoSQL database, or it can stored in a file system like HDFS. Okay, from that storage, as I told you for the beginning, for big data analytics, visualization tool come into picture. Okay, so this is the typical macro level level architecture for stream processing. Okay, so we started with big data analytics, that is doing batch processing. We are now at stream processing. Okay, so I have given what are the streaming processor. Okay, stream SQL, this is built on SQL. Okay, this you can query using SQL languages, SQL structured query language. Apache's Kafka is the prominent stream processing broker. Then Storm is there, Spark is there, Flink is there. Imply, that is a new software that is getting surging popularity these days. You can go to this website to understand more how it is doing streaming processing. I think it is developed on Flink. Okay, so Flink is a open source, but Imply may not be free. I'm not sure. Okay, Imply may not be free, but it is built on Flink. So the internal processing tool is Flink for this Imply.io platform. That is analytics in motion. That is why it is called streaming analytics. Okay, so similarly, there are several cloud-based streaming analytics platform like Amazon Kinesis streaming, Apache streaming analytics. Sorry, not Apache, Azure streaming analytics, IBM streaming analytics, Google Cloud Data Flow. These are all available in cloud. Okay, so clouds are available in multiple places across the globe. In India, Amazon Cloud is available in Mumbai. Azure Cloud is available in Hyderabad. Geo has 5 cloud centers in India, but it is a small scale cloud center. That means in each cloud center, 3,000, 4,000 servers are there. But in the case of Amazon, there are 25,000 servers are there in each cloud center. In totally, there are around 4 lakh server missions are available in all the cloud centers across the globe. Amazon has 13 cloud centers across the globe. In each cloud center, they have around 50,000, 75,000 server machines. Okay, Google is the world largest cloud center. It has 8 lakh, 9 lakh server machines. Okay, even your Gmail that we are every day using is running on Google Cloud Center. Okay, Google has a cloud center in Singapore, Ireland, and other parts. I'm sure maybe due to pandemic there is some delay, but it is anticipated that in 1 or 2 years time, most of the popular cloud centers will be made available in India also. In Bangalore, in Chennai. In Chennai, I know IBM has built a massive cloud center in Avadi. Okay, in Avadi area, it is not visible because it is underground. Okay, because of the security reason, the cloud center is underground, that you cannot see it. There are 25,000 servers are there inside that cloud center. It has spanned across multiple acres of land. Okay, so all the servers are there. Okay, in these servers they have installed all these analytics platform, streaming analytics platform. Now if you write the logic, you can put your streaming data and run the show. Okay, that's the part. So this is Microsoft streaming analytics architecture. This is the way they are doing my streaming analytics in Microsoft Azure. Microsoft Azure is the world's second largest cloud center. First one is public cloud wise. Amazon is the number one market wise. That is around 30% of the worldwide enterprise applications are running on Amazon Cloud Center. 18-19% of the applications are running on Microsoft Azure. Then 13-14% are running on Google Cloud. IBM has around 7 or 8. Oracle has 2 or 3%. Okay, so that is the market rate. So Amazon is the number one, Azure is the number 2. Okay, so in Azure, how they are doing streaming analytics. Okay, left side, there are so many IoT devices. As I told you, there are billions of IoT devices across the globe. Okay. And another thing is log. I told you what is log data, file data. Okay, then customer data, financial transaction. That if you buy a watch or dress in Amazon.com, that's a transaction. That's a buying in. That's a okay. So that's a transaction data, weather data. Okay, so now even weather applications are running on cloud. Okay, and business applications, all kinds of supply chain management, employee management, HR management, knowledge management, content management, all kinds of management applications, business applications are running on cloud. Okay, so that is the data sources. These applications, these platforms, these infrastructure, these devices are producing a lot of data. So the second one is data ingestion. Okay, event hubs, Azure Blob Storage, IoT Hub. These are some of the ingestion as well as storage mechanism. On the storage mechanism, you can apply analyze. Okay, once the data are stored, you can do the analysis. From that analysis, you can go to visualization tool. So you can casually, slowly go through these slides in order to understand the process, end-to-end process of converting your data into information and into knowledge. Okay, so this is again this is a cloud exclusively for IoT data analytics. Okay, so you see one side there are smart meters, then cars are there, then this is I think van or lorry, and the second one is I think it's a instrument hanging on doctors. Okay, so that's a doctor. Then there are mobile phones or smartphones. Okay, that gets connected via Wi-Fi tower. Okay, then Wi-Fi gateways are there. Okay, IoT gateways are there. So these are all some of the mechanism to collect the data, to transmit the data to cloud. In cloud, you can run so many processing systems, rule-based engines or storage, everything there in Aero Cloud. Okay, now from there you can visualize it. That's why you can show the map chart here on the right side. So now it is very clear for you how data getting collected, how it is getting processed, how it is stored, how it is analyzed, how it is visualized. Okay, so that's the end-to-end framework for data analytics. Okay, so now these are some of the applications of why you have to do data analytics on IoT data. As I told you, there are billions of IoT devices. Then these data are meticulously collected, and knowledge is getting collected and disseminated to various devices. You can just go through that. I will throw some use cases in the subsequent slides. Okay, so yeah, so yeah, there are streaming databases also. It's very recent phenomenon. People very recently realized we need streaming databases also. Okay, so we very recently leverage some streaming databases. That's why I got put this slide here. So along with the streaming data analytics, you need streaming data bases also. Okay, so streaming databases is a combination of streaming data collection as well as plus data crunching. These databases can do both. It not only collects the data, stores the data, but also it will do the data processing, data analytics also. So now there is no need for data processing systems separately. These streaming databases are a all-in-one system that collects the data, cleanses the data, ingest the data, store the data, process the data. Okay, so that is the advantage of streaming databases. So streaming databases is a collection of multiple technologies and tools that does everything. Okay, so once say data sources, then data streaming databases, then next data visualization. There is no need for data ingestion, no need for data storage, no need for data processing. So that is the advantage of streaming databases. Okay, so now this hybrid world. Okay, there are certain applications that needs big data processing. There are certain applications that needs streaming data processing. So the hybrid world is the combination of big data processing as well as streaming data processing. As I told you in the beginning, big data processing is all about batch processing. You collect the data, aggregate the data, and you do the analytics on the big data. Okay, but in the case of streaming data, you don't wait for even a single second. You collect the data immediately, crunch the data immediately, create the knowledge immediately, share that knowledge to the concerned system immediately. So that is the advantage of um, streaming databases and hybrid word. So you see the second word, the combination of stored and streaming data, streamed data. Okay, big data typically does the analytics on the data stored on a database. Okay, so you collect the data, clean the data, then store the data, then you do the big data analytics. But in the case of streaming data, you collect the data, you stream the data, you are buffering the data. Okay, you are not storing the data, then you apply streaming processing, then you store the data. Okay, so the storing data comes after processing as far as streaming data analytics is concerned. But in the case of big data analytics, collect the data, clean the data, store the data, then you do the processing. I think you can clearly understand the major difference between streaming data and stored data. Okay, for big data, your storage comes first. For the streaming data, processing comes first, storage is second. Okay, so that is the there is a big difference between this big data and. Okay, so this is the architecture for the hybrid world. The top one is for streaming data, fast data analytics. The lower one is for big data processing. Out of that, for structured data, some structured data directly it will go to streaming, CEP, complex event processing. Okay, streaming data analytics or complex event processing or simple event processing. Okay, there are so many nomenclatures for streaming databases, data analytics. Okay, so but in the case of big data, you will have structured data, unstructured data only. On structured data, you can do both big data analytics as well as streaming data analytics. Okay, on unstructured data, you can do only this one, streaming, sorry, big data analytics using Hadoop cluster. Okay, so this is a hybrid model. So based on the application, based on the use cases, based on what an enterprise needs, you can decide whether to go for big data analytics or streaming data analytics. Okay, so that is the. Now we are going towards cognitive data analytics. So this is cognitive era. Okay, you can see the progression of computing. Once upon a time, we were using tabulating machines. Okay, so some print card or something like that. I forgot the exact word. So you have to print everything in a card, and you have to insert the card into the machine, and it will read that. That's once upon a time, maybe some 50 years back. But then the personal computing came into picture. People can do assembly programming, high-level programming, object-oriented programming, all these things. So for that era, you need two ingredients, as I told you in the beginning. You need data plus you need programs, you need software application, you need logic. Okay, so that is programming era. So there are client server architecture, distributed architecture, multi-tier architecture, personalized computing, cloud computing. Okay, so many computing models came into picture. Okay, so these are all programmable systems era. So that means these computers are programmable. Okay, now we are entering into the cognitive systems, that is self-learning system, self-managing system. Okay, so you might have heard about the word autonomy computing. Now, madam, somebody told this is an autonomic institution. Okay, what does it mean? It is, as per my knowledge, it is not depending on any other university to give certification degrees. That's what I understand as far as autonomic institutions are concerned. Here also in the cognitive systems, it is autonomous system. That means there is very less intervention from human beings. Systems understand automatically what is needed, and it will accomplish that automatically. Okay, so that is the era we are going into. Okay, so that is cognitive systems, that is artificial intelligence era. Okay, so the futuristic system is cognitive systems. Okay, so I was giving the lecture on artificial intelligence system last month. Somebody asked me what is the difference between cognitive systems and artificial intelligence systems. Okay, as I told you, IBM Watson cognitive system is a cognitive system. Why? Because it crunches the data and it will tell the human doctor, this is what I found, so please do accordingly. That's what cognitive system will do. It will assist the data, assist the human doctors or humans. Okay, it will augment the knowledge of human doctors. Okay, so cognitive systems are assistant systems or augmenting systems, whereas artificial intelligence systems are the ultimate system that does everything, that takes 100% control. It doesn't depend on human beings at all. Okay, so that is the artificial intelligence system. That is totally automated system. That is called artificial intelligence system, whereas cognitive systems depends on cognitive system only assist or augment human beings. It doesn't take the decision by itself. It is not 100% automated system. Artificial intelligence or AI systems are 100% automated system. It doesn't need any intervention, any interaction from human beings. It will take the decision. It will automate everything. It will plunge into actions automatically. So that is the difference between artificial intelligence system. Why we are talking cognitive system these days? Because we are not yet compatible with the artificial intelligence system. We don't have the trust on artificial intelligence system yet. For example, IBM has a data analytics system. Okay, for the cognitive data analytics system, for the last 5 years, Wimbledon. Okay, before Wimbledon starts, IBM analytics system will predict who will win Wimbledon. Okay, before the match starts itself, it will clearly predict who will win the Wimbledon. Okay, but for the last 4 or 5 years, it correctly predicted whatever name it says, that person emerged victorious. Okay, but unfortunately last year it predicted somebody, but finally somebody else won the match. So still we cannot give the control to the system for prediction. So 100% trustworthiness is not possible with IT systems yet. That's why still we are going forward with cognitive system, not for artificial intelligence system. So still technologies have to grow a lot for the next 10 years, 15 years. It is going to be very crucial. Maybe 2025 afterwards, sorry, not 25. Already we are 2020, so 2035, that time we will have artificial intelligence system. That system will take the decision by itself, act upon it without any instruction from human beings. That is the prediction. Okay, so we are now in the okay, so why I have okay, so I go to, yeah, I go to 30, slide number 30. Okay, so cognitive analytics. Okay, so we discussed about big data analytics, we discussed about streaming data analytics. You know the differences between them, why we need streaming analytics or real-time analytics. In the case of airport use case, we cannot depend on big data analytics, we need streaming data analytics. Why streaming data analytics? Streaming data analytics is a real-time analytics. It crunches the data immediately, instantaneous analytics. Whenever there is some data coming in, immediately the data gets crunched, so that it can emit out the knowledge immediately. That knowledge can be given to policemen or business executives or IT experts to take the action immediately, so that any kind of bad things can be avoided, can be surmounted. Okay, so that is the need for streaming data analytics. Now we are entering into cognitive analytics. Another 10 minutes I will take, 9 minutes I will take, I will go very fast. Okay, so hopefully you might have gone through some FDP and artificial intelligence. So you might have heard about these machine learning, deep learning algorithms. You might have heard about computer vision and NLP, natural language processing. Okay, so cognitive analytics is mainly for doing some unique activities. If there is any need for prediction, if there is any need for clustering, if there is any need for detection, recognition, and translation, if there is any need for image title creation, then you have to go for cognitive analytics. Okay, so for any diagnostic, deterministic analytics, you go for big data analytics and streaming data analytics. For any kind of predictive analytics, prescriptive analytics, personalized analytics, prognostic analytics, you go for cognitive data analytics. Okay, so what is prediction? What will happen tomorrow? Okay, now third wave is getting predicted, correct? Of corona. Some countries they are already predicting fourth wave, fifth wave also. Okay, so these prediction are being done through cognitive data analytics. Okay, what is detection? For example, face recognition. Okay, face recognition is a cognitive data analytics. Why? Because today if you go to your office, I don't know about academic institution, but in our office we have to show our face in front of the camera. Camera recognizes my face, then only the door will open. Okay, so that is face recognition. So this is useful for many terrorist avoidance activities. For example, if somebody is entering into railway station or airport, cameras can capture that person immediately, and it will send the message to the airport policeman to take the action immediately. Okay, so detection, object detection. For example, in an image, whether there is any person or whether there is any dog or cat or any scenario or any tree or any car or whatever it is. For example, you know about self-driving cars. There is these cognitive analytics platforms are extensively used because the car has to identify there is a signal or any pedestrian is crossing the road or any car is coming in the opposite direction. All these things have to be detected, recognized, and translated into action. Okay, so cognitive analytics is mainly for such kind of actions. So what are the primary action? Prediction, clustering or association, detection, recognition, translation, image creation. For these activities, cognitive analytics is recommended. Okay, so you might have got some info where for which use cases we have to go for cognitive analytics due to some time constraints. I am jumping into. Okay, 1 second. So cognitive analytics, then the next slide is talking about artificial intelligence algorithms. Machine and deep learning are artificial intelligence algorithms. Then artificial intelligence applications, computer vision and natural language processing are application. For example, if you are using iPhone, iOS phone, then you might have heard about Siri or what is that? I am using Android, so this Alexa, Siri, these are all some of the NLP applications that are using cognitive data analytics platform in the background. Okay, so that is the applications of cognitive analytics. Okay, so that is the 34th slide. Sorry, 31st slide. Then 32nd is cognitive analytics enablers. Okay, so you can go through that. Machine learning algorithms. There are so many machine learning algorithms, supervised, unsupervised, semi-supervised, reinforcement algorithms are there, random forest algorithm, decision tree, SVM, regression algorithm, k-means clustering, so many. 13, 14 algorithms are there for machine learning, deep learning, CNN, convolutional neural network, RNN, recurrent neural network, LSTM, long short-term memory, and then gradient algorithms are there. So, so many algorithms are there for RNN, that deep learning algorithm. So then there are so many frameworks, TensorFlow, you know, PyTorch, Cafe. There are 30 plus MLDL frameworks are there in libraries are there and the accelerators are there. Okay, these are all enabling cognitive analytics. So finally, there are a lot of works going on the fourth aspect. These are all the research side. Okay, very less products available for pruning, quantization. These are all some of the optimization techniques. Okay, so I have been going through some research purpose on that out of excitement. So if I get some time, I could have explained this on for hours of time, but unfortunately no time. So I am jumping into the next slide. So this is the process. You train the data, test the data, update the data, do the optimization, then you do the deployment. Okay. There are so many automated deployment tools, ML apps, model apps, data apps are there. So these are all primarily leveraged in cloud centers, in academic, sorry, in industry arenas. So you will hear more about that in the days to come. So when you hear from artificial intelligence experts, you will definitely hear all these things. Okay. So there are several use cases for cognitive. Okay. So finally, uh, you all do that. But whatever system, whatever application, whatever data, you need a infrastructure. Correct. So cloud is an infrastructure. Okay. Azure cloud is there, Amazon cloud is there, Google cloud is there. So therein you have to get some server machines, some storage machines, some new network solutions to deploy your application, to run your application, to execute your application. So cloud is the very prominent environment today. Today, most of the applications are running on cloud. Okay, I don't know about your college. Your college has a website. That website application is running on your own server that is inside your college, or you are running on cloud. I do not know, but some infrastructures are needed, whether it is on-premise, private cloud, or it can be off-premise, public cloud. Okay, so you need an infrastructure to run your big data analytics platform, streaming data analytics platform, cognitive data analytics platform. Okay, so another interesting phenomenon is edge cloud. So another 2 minutes. So edge computing is very popular. I don't know, you might have heard about that, but in the days to come, definitely edge will be very popular. Even Gartner has predicted that in another couple of years' time, there will be very less focus on cloud computing, very huge focus on edge computing. Okay, what do you mean by edge computing? For example, you know TensorFlow. TensorFlow is a open source MLDL framework that was open source created by Google. It is freely available now. Currently, this TensorFlow is running on all the clouds, all the Azure cloud, Amazon cloud, Google cloud. But in future, these TensorFlow will run on your own device, your cell phone, your camera, okay, your Wi-Fi gateway, or in your own refrigerator, or your own TV inside your home. All kinds of devices will run TensorFlow. That is called edge computing. That is edge devices. You are running your TensorFlow to do the analytics, because your TV or your refrigerator generates lot of data. That data gets generated in the refrigerator. Instead of sending the data to far away cloud, you collect the data in the refrigerator itself. You run TensorFlow. That means where data gets generated, there TensorFlow is there. So immediately the data can be crunched. That is edge analytics, or edge cloud, or edge devices, or edge infrastructure, or edge application, whatever it is. Okay, so we have developed a edge product. So due to time constraints, I am not doing any demo on that. Okay, this is a analytics on cloud. Okay, so you have sensors in your home. Light sensor, gas sensor, temperature sensor, smoke sensor, humidity sensor. I mean, slide number 39, it will go to cloud, Amazon cloud. Then if there is any possibility for fire in your home, okay, then it will inform to the fire people, or government people, or police people, or even the house owner. So if the house owner is not in home, for his mobile phone, the information will be sent. So this is happening on cloud. But in future, this analytics will happen in your own sensor itself at your home. The data doesn't travel on the internet to cloud. Okay, so that is the future. Sorry, I can go on. So sorry, I stop here. I overshoot only 1 minute. Okay, thank you so much for listening to me. If there are any questions and any doubts you have, you can send out the question to my email ID, peterindia@gmail.com. you can definitely get the answer from me. So sorry, I could not spend my time on question and answer. Thank you for listening to me. If you want, you can get the slide from that professor. You can make use of it. Okay. So I have not put any confidential information. All are publicly available, so you can go through that. Thank you so much.
Thank you, sir, for taking the time to lecture about a very important topic on nowadays, data analytics. It was really subjective and informative. Thank you so much, sir.
Thank you, madam.
Dear participants, attendance links is posted in chat box. Do it before the second session begins. Attendance link is posted in chat box. Do it before the second session begins. May I request Dr. Rosalind Selvarani, Assistant Professor and FDP Coordinator, to thank the speaker.
God renders in the thankful heart. On behalf of our department, I thank you for your knowledge sharing on the topic integrated data analytics. We had a clear understanding of automated data analytics, big data analytics, streaming data analytics, cognitive data analytics, and application of all these analytics. Thank you so much, sir. We have already posted your PPT in our WhatsApp group for the further references. Thank you so much, sir.
Thank you, ma'am. Let us take a 30 minutes break and reassemble sharply at 11:30 a.m. here for second session. Let us take a 30 minutes break and reassemble sharply at 11:30 a.m. here. Thank you.
Friends, please note, all the participants are requested to join in the meet at least 10 minutes before starting the next session. Thank you.
Hello, Revati? Hello? Hello? Hello?
Hello, miss.
Hello, கேக்குதாடா?
Yes, miss. Yes, miss.
கேக்குதா? வாய்ஸ்
Yes.
கிளியரா இருக்கா? Okay.
Yes, miss. Yes, miss.
Okay, video?
Yes, miss. Yes. It's clear.
Okay, thank you. Okay, thank you, Revati.
Okay, miss. Okay, miss. Okay.
Rosalind, ma'am, shall we start the session, ma'am?
Good morning, sir.
Yeah, good morning.
Good morning. Shall we start our session, sir?
Yeah, please.
Participants, we are about to start the next session. The resource person has already arrived. Please join the group soon. Kindly mute your audio.
Welcome to the second session of Faculty Development Program.
Yes, ma'am, please.
Anyone who stops learning is old, whether 20 or 80. Anyone who keeps learning stays young. The greatest thing in life is to keep your mind young. A smile reminds the universal welcome. It's my pleasure to request Dr. N. Karpagavalli, Assistant Professor of Computer Science, to introduce the speaker and deliver the welcome address.
Thank you, Emima. With note of acknowledgement to the Lord Almighty, it's my pleasure to extend a cheerful welcome to all of you. It's a glad welcome I bring to you this morning, filled with the desires, hopes, and dreams all of us share. It's my pleasant privilege to welcome and introduce Dr. R.B.V. Subramaniam, Professor of Computer Science, Chief Investigator of Electronics and Information and Communication Technology, Academy, working in National Institute of Technology, Warangal, Telangana, to today's Faculty Development Program. Sun has rendered services to professional bodies, the Joint Honorary Secretary, Institution of Engineers, Warangal, Local Center from 2010 to 2012, and Honorary Secretary for sessions 2012 to 2014. And also, Sun is a member of several professional bodies, a senior member, IEEE, and associated member, Institution of Engineers in India. His areas of interest comprise of machine learning, pattern recognition, algorithms, high performance computing, soft computing, and outlier analysis. Sun is the chief investigator in electronics and ICT academy at NIT Warangal, set up by Ministry of Electronics and Information Technology with a fund of rupees 25 crores by assigning Telangana, Andhra Pradesh, Karnataka, Pondicherry, Goa, Andaman and Nicobar Islands as jurisdiction. It has received various funding grants from NIT Warangal for his research projects, supported and recognized by MHRD, Government of India, with Indian Institutes of Technology, Kharagpur. Sir is a multi-skilled person with deep knowledge in the data mining and big data analytics, distributed data mining, graph databases, pattern recognition, and soft computing, logistics arena, and has more than 12 years international experience to his credit. He has performed duties from different locations and capacities such as a chief investigator, co-chief investigator of sponsored projects, coordinator, associated dean, deputy registrar, technical committee member, additional secretary of national level MCA entrance test, library advisory committee member, technical member, session chair, organizing committee member, member of editorial, chief editor, chairperson, etc. He was the reviewer for IEEE transactions on fuzzy system, information sciences elsewhere, Journal of Information Knowledge Management, World Science, also reviewer for some international level conferences. His areas of research cover association rule mining, temporal data mining, sequential pattern mining in the domain of data mining, and also big data analytics, distributed data mining, graph databases, fuzzy data mining.
Under his able supervision and eminent guidance, 8 candidates have been awarded PhD and 2 are pursuing the research on various state-of-art topics in computer engineering. Sir has authored and co-authored more than 50 research papers at various training programs, international and national conferences. He has been organizing many international IEEE and other conferences and has been an active speaker as well as member of their technical and organizing committees. Apart from that, he has acted as the coordinator and resource person of 40 refresher courses and workshops. We are privileged to have such an eminent personality amidst us. He graciously accepted the faculty development program invitation and consented to share his expertise on map-reduced computing with us this day. I wholeheartedly welcome you, sir. A special word of welcome to the FTP participants from far and near. I extend a hearty welcome to my fellow colleagues, each and everyone who work behind the screen tirelessly to organize this 5 days online faculty development program on integrated data analytics, the tools and applications across industry verticals. Once again, I cordially welcome each one of you.
Thanks for the cordial welcome, ma'am. May I hand over the session to Dr. RVB Subramaniam to share his expertise on map-reduced computing paradigm with us. Please, sir.
Thank you for introducing me. It is my privileged opportunity to associate with Atal Academy supported programs. I'm happy that you are organizing one such on covering various aspects of analytics. And she nicely introduced our Electronics and ICT Academy, which is supported by Ministry of Electronics and Information Technology. Initial jurisdiction was Andhra Pradesh, Telangana, Karnataka, Pondicherry, and so on. But now it is extended to throughout India. Now, in fact, we have been organizing several programs in Tamil Nadu, some in Kerala. I request those who are interested in organizing faculty development program may approach us with a request. The request format is available in our website, E&ICT Academy of NIT Warangal. You can just send the request, and you have to see that at least 50 participants register at online FDP. Each candidate has to pay 750 rupees towards 40-hour lecture program on topic. The topic can be chosen by you, which may be any curriculum based or thrust area covering electronics and computer science engineering, information technology, and any component involved in ICT, including the OBE, outcome-based education, and NBA accreditation introduction and all. Once if you pay, each participant, 50 participants pay, at least 50, pay 750 rupees, we will be getting only 37,500, 50 into 750 rupees. But we shall organize 4 hours per day into 10 days or 5 hours per day into 8 days, long hours, and we take care of arranging the lectures, and we pay the honorarium for the resource persons. Nearly we have to spend nearly 1,15,000. This 1,15,000 minus 37,500, we meet it from the project. The project is up to March 2022. I request the participants, whoever participated from various colleges, to come forward and utilize this opportunity. We are nearly spending nearly 75,000 from our project for each FDP. And you can choose any topic of your interest. we'll arrange it. If it's a very good institution, we give little freedom to schedule the topic, schedule the lectures also. That's how we have been organizing. You can look at it. We have trained nearly 18,000 faculty in the last 4 years by conducting 420 programs. This is our setup, and we have been assisted by several of my colleagues at NITs and my friends at IITs and industry. The programs are well received. Now on the outset, I thank the organizers for inviting me and asking me to introduce this map-reduced computing. Maybe they would like to cover the other topics of analytics based on this MR computing, maybe implemented in one of the ecosystem. This map-reduced computing, of course, introduced earlier, but it is now predominantly used in the context of big data analytics and processing. Fine. Why this MR is suitable for the big data, and then before that, what is big data, that also we have to look at it. And then we enter into the MR computing. How do we write this MR computing based logics so that they will be implementable on Hadoop-like systems. Now, it is, of course, due to pandemic, we are unable to have an interactive session. However, those who are interested to chat with me, they can give in chatting so that the organizers will allow them to speak, and thus we can clear the doubts. Now, I expect quickly someone to give in chatting what is big data. What do you know by big data? Perhaps already one session is over, they have introduced it. No one? Yeah. Someone has written that data which is big computing engine, collection of large volume of data, variety volume data from different sources, varied types with greater velocity. Fine. Yeah, they have nicely covered the characteristics of big data. The volume, velocity, variety, and one person, in fact, they said that it is collected from various sources. That's also a good point. And of course, something relevance and all brought. Yeah, I was also a little confused with these characteristics at the beginning. Nearly around 12 years back, when we really entered into this domain. When I looked at the same definition was there for the big data, volume, velocity, high volume, something like that. But I was skeptical about what do you mean by high volume. Is there any limit that beyond which it is big data, otherwise it is small data? And because I have not seen data which is not having volume. Every data will have volume, but the question is, when you said high volume, what do you mean by high? Any threshold is there? That's the point. And when you insisted on velocity, because time is a little bit vast. If you think that I'm a bit harsh, you can control me. Velocity. The velocity, whether velocity is also a very essential and compulsory characteristic of the big data, that I don't know. Whether have you seen any data having velocity or because there are some static databases which we do not change. Then what about it? When you say velocity zero, what is that? What do you mean by that? Hence, we have data streams where data flows with some velocity. Definitely, it is great challenge to handle such a data stream where data is flowing, because we have very limited amount of time where we can look at and process the data, because later on it will go off and you cannot collect it into any storage because the data stream is flowing with velocity. It is a sequence of that. Hence, it is not the question of storing it and then processing at the storage point. Hence, that is the way that we have dealt data streams the last 20 years, more than that, nearly. Hence, the question is data having volume, data having velocity and variety. Generally, even one small database, always we are very much interested to handle the variety of the data and veracity and all. So many other V's have been added. But my confusion is how many V's are there? How do you know that my data or given data is big data or not? Because unless you are clear whether it is big data or not, you cannot apply big data processing techniques. Hence, one should have the clarity on what is big data, what is not big data. Yes, now people are going on adding veracity, value. Yes, everything valuable data only we want to take it. If it is not valuable, generally we don't want to take it. That's fine. Veracity is the one what we deals with the ambiguity. Sometimes there may not be ambiguity. Hence, out of these so many V's, if people, other participants, if they look at the chatting, so many V's are coming up. Hence, whether all these V's or how many V's, and even for each of the V's, as I said, volume and all, any threshold is there beyond which it is called big data. How do we get? No, if I show you some, this is what exactly, it's very clear, unambiguously you can tell. If I give some fruit, you may name it if you know. Similarly, anything, no, if we think at least certain things which are imagining, okay, this is by imagining it, we can say yes, it is there or not. And some are physically, we can look at it, some are we can feel it, we can imagine it. But when it comes to the big data, do you have clarity? What is big data? What is not big data? That is the point. Yeah, Sivaram Krishna Shakshi is telling that the threshold of the volume depends on the emission power. Hence, for one system, it is not big data. For another system, it is big data. Okay. Is it not? Hence, I was a little confusion about these V's. I don't know how the rest of the world is understanding at that time. Then I was thinking, who has introduced this big data? Will it be there? Should I jump into this and do some research or not? Of course, now already 4 to 5 good PhD students they have done, and they are all well settled in different NITs and all. That's fine. We have been doing some little contribution here, and I have organized 2 international conferences on big data analytics with all IIT Delhi and all this. Fine. But at that time, I was a little worrying about how to understand it. For me, I can't pretend. I know big data. I know big data. No, I cannot. That's the problem. Even before introducing to the class, we were all in doubt how to understand it. Then I was thinking, what is the source? Source of this, who has formulated this big data word and all. Then I found that origin is somewhere else, that is in the distributed systems. If one person has given this hint that it is from different sources. Hence now, if you consider these distributed systems, and perhaps you might have studied some of the courses like distributed computing, distributed databases, distributed operating systems. When do we go for a distributed system, leaving a centralized system? You are happy with a centralized system initially. See, I have some centralized system. Even for that matter, you take a desktop or you have laptop, you are happy with that. You may be loading your program data, it is helping you, you are running it fine. Then why you want to switch from this system to something called distributed system? Because after some time, no, you will feel that your system, single system, is not meeting your expectations. The performance is going down. Then when you say this, your friends in electronics communication engineering or some other people, they will tell that add RAM, this, that, and so on. Then whenever you add a RAM or something, which we call it as scale up. Hence, whenever you scale it up, the resources in that, then it will perform little bit okay, fine. But again, after some time, no, you will feel that that degradation is there. The performance is not up to the mark, up to your satisfaction. Then what you will do, you will throw this away and purchase much bigger system, in the sense high configured system. Fine. Again, story will repeat. After some time, again, you will be adding the scale up and so on. Finally, they thought that this kind of investment on these kind of systems. Now, one HCCCS 2021, you have to mute it. HCCCS 2021, please mute it. HCCCS 2021, whoever is that. Yeah. Now, see, to end that, they thought that don't throw it away when you have some system which is not performing. And still yesterday it was performing fine, but today only the problem started. It means we have some amount of data which is cannot be kept in it. That's why you want to go for much bigger system. Then what you will do? You are throwing away, purchasing much larger system. Now, what I am suggesting, don't throw it away. Keep that, and whatever the amount that you can put in that, you put it. Now, someone has to tell that HCCCS. I'm getting a lot of disturbance.
Sorry for the interruption, sir. Participants, you are requested to kindly mute your audio, please. Participants in both the link, you are requested to kindly mute your audio, please.
No, all have muted. What is this HCCCS 2021?
So, through that, one more Google Meet link is connected. So she has to be unmuted always, but we'll see whether this disturbance won't occur. The future previous session it was not disturbed. We'll see whether some other things are okay.
Can't you disconnect it? Yeah, now I think it's fine. No. Can't you remove her? Well, the sound packages. Yeah, fine. Hence, now what I advise, you take a system, whatever the load, of course, up to which you are satisfied with its performance, keep that. Don't load it too much. If you have remaining data and all, you take a similar system and push it in and interconnect them. If two systems are not sufficient, you go for third or certain number of systems. Like this, you can go for this scale out. Since this is big idea, scale out. Since you can have as many systems as you want. Of course, there is a limit for that, and you can do this way. You can keep the data. Hence, now here what happened? Your data is not in one system. Data is distributed over some systems. Then there is challenge to handle this distributed data. Hence, we have distributed systems, distributed databases, and so on. Now, what are the challenges in handling distributed data? When I have everything in one system, what was the easiness? And when we move to the distributed system, what new challenges that I have to face? That is one point. And any changes that I have to make at the computing level or processing level, that we have to see, second point. And now, first of all, let me quickly introduce that. Now, what happened? Here, you have a single system which cannot hold your data, and hence you went to the multiple systems which are all interconnected. But simply the interconnection of autonomous computers won't be a distributed system, because what we have got is only computer network. Because computer network is interconnection of autonomous computers. But on top of this, you need a layer, some holding some OS kind of thing, which may be capable of dealing with the underlying systems. Hence, now let me load a distributed OS on top of it. Now, what happened now? Given the program and data, what this distributed OS will do, same thing what our OS is doing. Hence, now once if I have programs and data, OS is helping us to execute the programs. Fine, okay, with available resources in it. Similarly, this distributed OS will help you to execute these programs and on data with the help of so many systems beneath it. That's what expected functionality. Okay. Now, will there be any advantage? Definitely, there will be an advantage. One advantage is since not only single systems, several systems are being involved, you may get your work done quickly. That may happen. Okay. Hence, first thing is if there is parallelism to certain number of systems, definitely you will enjoy this quick disposal of jobs, because now you are involving several systems, whereas a single system has to do means it will take a longer time. Similar to the one, if you want to prepare all the dishes, it will take a longer time. If you have 2 or 3 friends, fine. All you 3 people can share the load and make the lunch quickly. That's fine. But if too many cooks, then there will be a lot of communication overhead, and you know that too many cooks will spoil the point. Fine. Now, so there is some limit. Now, that is one advantage. When it is advantageous, why not every person go to distributed system? why to work on centralized system? What is the problem? That is important thing which we have to discuss. Okay. The difficulty is see, whatever the program that you are writing at present in C or C++ or whatever the language may be, is OS is directly can it handle it? My question is, can OS understand your C program or C++ program? Can it execute the C program directly? No, we need a compiler. Hence, say compiler is there. Hence, it is taking this high-level program because it is high-level means OS cannot understand this program. Therefore, this is called high-level. And someone should translate it to the mission understandable level. That is what the compiler is doing. Hence, compiler is generating the object code, and object code is taken by the OS, and it is doing. Therefore, when I said that there is distributed OS, you cannot give high-level program. We have to give the low-level program only. Hence, low-level program which is written in MPI. Okay, kind of thing, we have to write it in and give it to the distributed OS. But is it so easy to write a program in low-level languages? You can imagine it. Perhaps some of you have studied this low-level language, how difficult it is to write the programs. Yes, now many of the people, irrespective of whether they are in computer science or not, including the farmers, they are able to handle with this computer. It's only thanks goes to compilers and user interfaces. Since user interface are there, simply we are giving certain parameters by clicking this button, that button, and then something program that is being activated, and it has taken the parameters and it is executing. That's what happening. Okay. Similarly, compilers are there which are able to translate our high-level program into low-level program, and the works are being done. Okay, this is how the compilers and user interface are helping many other branch people to work with the systems. That's what happening. Okay, hence here also it is difficult to work on distributed OS, though there are advantages. Once upon a time, there were hardly 20 people in India who can work really on distributed OS by writing the low-level program. The program is supposed to handle not only writing your the algorithm for the problem. Moreover, it has to dictate how data is to be distributed. When a system has to generate some output, and from this system to which system it should go, and whether any synchronization has to take place, are we putting any barriers, and several things which we have to find details of executing the whole logic is to be written. Otherwise, OS cannot do it on its own. OS, after all, it will execute whatever you give it. But of course, that should be in the object level. That is low-level programming. That's the problem. Therefore, though there are advantages, because of this difficulty, this did not become popular. Only a few people used to enjoy it. Now people thought that why only few have to enjoy these benefits? Why not we extend it to large masses? Hence, that is how, in fact, the people have started thinking it. Hence, then, first of all, what are the advantages? First of all, tell me. One thing is, you can get your get the work done quickly because your jobs are being completed with the help of several systems. Hence, there is a lot of possibility that your work may be quickly finished off. Not because it's not just only one system is involved, several systems are involved. Of course, every rule has exception. Now, second thing is, for one particular reason, you went to this distributed system. Suppose if you say, I don't want my work done quickly, sir, let it take no problem, any amount of time. I don't want to go to distributed system. Okay, then so you don't want to have this advantage, fine. But there is another necessity. What made you to go to the distributed system? That can you recollect what I have told? I have already told the another advantage, which is in fact a necessity, that which is forcing you to go to this distributed system. Can you recollect? I have told already. How many of you grasped that? That is the second advantage rather than it is the necessity which is taking you to the distributed system. Can someone chat it? The necessity is I have some data which I cannot keep in one system because it cannot hold it, it has some limit, but still I have some more data. Hence, what to do? Either I have to throw this system away, purchase a larger one, or keep that some part of data and remaining part of data I am storing it in the second system. Even that is not sufficient, go for the third system. Hence, in that context, one should go to distributed system. Is it not? The people who have chatted so far, will you agree with me for this particular one? Now, let us analyze this particular situation. What you are handling? You are handling with some kind of data which is not supposed to, which cannot be kept in one system. Which cannot be kept in one system means which is not bearable, which cannot be processed by a single system. It means it is big to that system. Say, I can lift this particular duster, no issue. Hence, this particular object is not big to me because after all I can handle it. But if someone asks you lift this bird, is it possible for me? Then I will say it is big to me. When it is big, definitely I ask someone to help or share this load. Hence, I am handling the data which is big to a system, that is called the big data. Data that is big to a system is called big data. Therefore, whenever you have such a big data, you must distribute it. Hence, big data is the one which must be distributed and then process it. As long as if you can keep in one system, how do you call it as big data? It is not big to that system. You are able to handle it. Therefore, in one way, the big data becomes some synonymous to distributed data. Because big data, immediately in your mind you should get that, oh, this big data became big to some system, therefore that perhaps distributed. Hence, the moment you say, someone says big data, then immediately into your comprehension what you should get. Oh, since it is big to a system, they might have distributed over some systems. Therefore, it is distributed data. Then the point is why they have given new name big data. They would have called it distributed data itself. Hence, I hope all of you have got my simple definition. Data that is big to a system is called big data. Data that is big to a system is called big data. What do you mean by big to a system? When it alone cannot process it, definitely only part of it will be processed. The rest it has to be given to other systems. And several systems are together, they are processing the data. Hence, we have such a data which is big to a system. Watchman, man having watchman. Do you agree with the definition? Fine. Do you agree or not? That's a different story. But this data, big data, you have to think in these lines that data which is big to a system is called big data. Fine. Then why they gave this new word, big data? Because now when you say that it is difficult to write programs for distributed systems, what is the easiest way? Suppose I have high level program, because I don't know how to write the low level and I have data, but I want to get it done on distributed system. What is the only way? Because just now we said thanks to compilers and all. Hence, why not you have some compiler here which can be loaded on top of this distributed OS, and then you give high-level program to compiler. Compiler will in turn give object code which is understandable by the distributed OS, and distributed OS will do it. This kind of structure you may propose, but the question is compiler which is suitable to generate the code which can be understood for this, is it difficult? Sir, after compiler will execute the translate the code, whatever you write high level program. Is it difficult or easy to write every minute kind of execution details in the high level program? How do you expect that there will be difficulty in distribution and all? How to answer those queries? And compiler, is it independent of OS or not? How many distributed OS are popular? After all, here what you are suggesting, distributed OS is one software A, let me call whatever it may be, software A. Compiler is another software. Hence, you are asking me to load another software called software B, compiler. Hence, now software A and software B, your program should go to B first and then A and then get it done, and then again in the reverse order you have to get the results. Is what you are suggesting. Then people thought, can I have some single software which is A union B? Hence, you are saying A union B. You are simply telling, load my software which will accept your high-level program, whether compilation will be done first and then execution, whatever, it doesn't matter for you. Doesn't matter for you. It is after all black box. It is a software. I am preparing a software which shall understand your high-level program, and it will process the data with the help of several systems beneath it. If one can be successful in designing such a single software, where you have this both distributed OS and compiler, whatever it may be, I don't know how to generate it. If you can have such a software, then such software can help you to handle which kind of data? The data which you are expecting to get it done on distributed system. What is that? Big data. Because why you want to go for distributed system? You cannot keep your data in one system. Data is big to a system. Cannot keep or cannot get it processed for several reasons. A single system, you feel that it is beyond the capability, beyond its capability to store, process, run, whatever it may be. Therefore, it is big to a system, hence you want to go for that. Therefore, you have some software which will help you to handle big data. Therefore, it is supposed to call it as, this software comes under the category, the technologies which are helping you big data. Hence, first such kind of thing, in fact, came up, that is the Hadoop. Hence, Hadoop is a software which will take your high-level program and data, of course, big data, and then it will process with the underlying this one. Once Hadoop came, and several other companies also come forward, they want to have their own ecosystem. They call it, this word ecosystem is introduced nicely, and they introduced Hadoop, Spark, okay, so many other things, Neo4j for graphical databases and graphical data. Hence, so many ecosystems have come up. All those technologies come under the umbrella called big data technologies. This is the meaning of the big data. That's how I can introduce it. Hence, big data is data which is big to a system. First point. Therefore, big data must be distributed, and hence we have to involve several systems and to process it. But for that we need someone which can understand my high-level program and take data, distribute it, and my program also to be distributed, and work should be done. It should be distributed. For the reason no single system can handle my data and program. Therefore, you have to go for that. and we need a software which will understand my high level program, because there is another fellow, distributed OS fellow, but they are also the distributed systems fellows. If I go to distributed system people, they will ask me to write the low level program. I can't. Hence, I can't go to distributed system fellow. But there is another shop where big data technology fellow, here he is accepting my high level program. Hence, there are two shops. Either you go for big data technologies, give your high level program, get work done. Second one, write low level program, minute details, go work on distributed system. There are two things. Which shop generally people choose? This is easy, big data technologies. But unfortunately, there are limitations. Every problem, every program, you cannot write it. This hard big data technologies are unable to understand and process it. Therefore, there is some limitation. Therefore, we cannot close the other shop. The shop distributed system people, once if you can write at the low level program, this is more efficient way of handling it. Therefore, this shop, though it is very rarely, few people only go to this, the shop cannot be closed, because this will not become alternative in every aspect for every problem to the other shop. If no one goes to this first shop, no, this distributed system, definitely it will be closed. But still people are relying on this. Therefore, they don't want to change this word. They want to reserve this distributed system, distributed data, this word separately. And they want to open new shop called big data and big data technologies, and they want to improve slowly how it will allow the ecosystem will allow handle several kinds of data and program. This is being expanded. Its jurisdiction is getting expanded, and slowly the dependence on distributed systems may go down. We don't know, but still there are some limitations for this. That's the problem. Okay, fine. I hope now you understood difference between data which can be handled in one system, data which is beyond the capability, which is called big data. These two are clear to you. Therefore, big data should be taken to the distributed system only. But there is conventional distributed system, or the other one is you can well give high level program, and there are big data technologies available, which is also as good as working on distributed system. And here the labor is less, because you can give simply high level program, hence you can choose one of that. But mostly the who are not well versed with writing low level program definitely go for this. These are the two things. Any doubt at this stage? And then now I will enter into what are the challenges when you go to the distributed system, and how do we handle it, and thereby I will bring that MR computing into the picture. That's how I'll bring it. Quickly in 2 minutes, if you have any doubt, just chat it, otherwise I will continue. Now, what is the question of the cost effectiveness means? First of all, when you don't have a system where someone is asking how it is cost effective, the question is when you don't have a single system handling your thing, you have stopped, no, you are unable to run it. Then at any cost when you want to run it, do you prefer there is something where some 5 systems or 10 systems together are helping you to get your data processed? Do you go there or not? Because you cannot keep it in single system. Therefore, considering better problem is solved with cost rather than problem is unsolved, therefore you will go to for that. That way I want to cut short, but there are a lot of things we can discuss as far as the cost is concerned. Visibility of the board, I think it is it is there for all, maybe 2-3 people, because this is my style of giving. Almost daily I give the lectures on several topics. Even my courses I deliver it. whoever that problem, visibility problem, may be due to bandwidth your side. Yeah, may not be the problem for all. Fine. Now let me highlight what is the difficulty, big challenge. First of all, there are many, at least salient things. What are the big challenges that you will face when you move from centralized system to distributed system? That's the point. And in centralized system, you have everything in one system. Since your entire data program, entire data, everything is in one system. Your program can access entire data. That is advantages. You may not feel that advantages or not. If I say you are able to breathe, you are able to talk, you are able to listen, you are able to see. Hence it is advantage means everyone say, what is this nonsense? I am able to talk. Advantage means you go to the person who cannot talk, then you will feel whether your advantages or not. Similarly, this is advantages because your program can access entire data. The moment you go to the distributed system, no system is having entire data. Here a part of the data is there, here another part is there. Part A, part B, part C. Hence your data is distributed. No system is holding entire data. Therefore, even if you copy the program, if it is small, it is there in every system. Unfortunately, program cannot access entire data because this particular system is having only a part of it. And program in another one is having another part. Therefore, program is unable to access entire data. Centralized program is able to access entire. Here it can access entire data, here it cannot access. Therefore, the program, the algorithm will not work. Just for simple understanding, you have single source shortest path algorithm. Say the Dijkstra. Shortest path. From single source to several lists. Hence, what you will do? You will load a graph in one system by adjacency matrix or adjacency whatever that. This graph is loaded. You are loading the Dijkstra algorithm program. Then program has accessing the entire graph. And from single source, what is the shortest route to each and every other node? It will find out and tell you. Fine, over. Means you want to find shortest path from Kanyakumari to every other city in India. Fine, you can do that. Only thing is you have to give India graph. Give it, it will find out. This algorithm. Fine. But suppose your India graph is a big graph, which you cannot load in one system. Then what you will do? Oh, sir, graph is big to a system. Big data. Hence, I have to distribute this graph, India graph, over some 10 systems or 35 systems. Suppose 35 states are there, you distribute this state-wise. Hence now in one system you have Tamil Nadu, in another system you have Telangana, in another system you have Kerala. Now, even if you load the copy of this algorithm, that program in every system, and you ask in Tamil Nadu, from Kanyakumari to Delhi, it will say that Kanyakumari is there, Delhi is not in my list. It cannot run, Distra cannot run. You ask Telangana, here you run that Distra, give single source and that destination Delhi. It will say neither Kanyakumari nor Delhi is here. Therefore, your Distra algorithm won't work. Since for that matter, many algorithms which you have studied in various courses, your programming courses, in data structures where you have associated some algorithm, you are associated data structure for better performance, and even design and analysis of algorithms course. All those algorithms are written with one assumption. The assumption is unwritten assumption. The assumption is the algorithm, the program, whatever you are writing, access entire data. Hence, for that matter, all the programs which we have studied so far, mostly written for centralized system. They won't work on distributed system. Hence, prior to this problem was unsolved. But nowadays, the graphs are so big, you cannot load them in one system. Therefore, this won't work. In big data, we have parallelly, if not that much efficient as Distra, we have a better another algorithm. Definitely, when you can load data in one system, Distra is best one. I agree. But when Distra is unable to work in a distributed environment, I am relying on another algorithm which is less efficient than Distra. But I have to, because otherwise problem will be unsolved. It's like that now all these old algorithms are becoming obsolete. We have to develop in parallel the algorithms which will work on a distributed environment, that is using big data technology. That's what we have to do it. That's why we are now here. Hence, this is the problem. Hence, program accessing entire data is very crucial. When you don't have this, when you have each system is having only part of data, then how do we process it? How do we get the same result as if entire India graph is loaded in a single system? Suppose I don't have single system. Suppose someone builds such a huge system, then India graph can be loaded, suppose. Then whatever the result we get because of the single system, which can hold the entire India graph, should be obtained on a distributed system where I am distributing the India graph, that is state-wise. Answer should not be different. It may take more time, less time, doesn't matter. Answer should be same at least. And then slowly we concentrate how to reduce the time complexity, how to get the things quickly done, all these issues, other issues. First of all, we are now worrying about how to write algorithms which will work on distributed systems. That's the point. Okay. Then it is something like, now you are looking at some animal. Suppose you look at an animal through a window outside. Okay, there is a big animal. Of course, if the window is small, the animal is very big. But still you are able to see that through the window and you can figure out, oh, that is elephant. I am able to see through this window and there is an elephant on the ground. What happened? My brain is able to see, my eyes are helping me to see the entire animal, and my algorithm here processing and comparing with the animals which I know, cat, tiger and so on, and I figured out, oh, this is animal. Now, on the other hand, this is what is happening in the centralized system. You are able to see the entire animal. A single person is able to see it and recognize that it is an elephant. Now, let us switch to another situation where the elephant is brought into this building. This building is a huge building, 5 rooms in each floor, 3-story building. Suppose I cut the walls this side and I bring that elephant into this, because the elephant is also so big. It has spread over 5 rooms in each floor, 3 floors. Such a big elephant I have brought. Now elephant is like this. No? Now elephant is distributed over 15 rooms. Now I will ask my 15 colleagues, let us enter into these 15 rooms at a time and look at what we'll see and come out and discuss what is that animal which has occupied these 15 rooms. Now what will happen? One fellow who is entering into this room will see only the leg part. Because this fellow who is seeing here, unlike I'm seeing through this window, no, he can't access the entire, he can't see the entire animal. He can see only a part of the animal. And he got the knowledge about that part only, because he can't see what is the other parts. He entered into this room, he has seen only one part. Similarly, this is the same thing for each fellow. Each person who is entering in a room can see only a part of that. And if you ask them, what is this? This is something like a trunk. Some fellow who is touching that tail part, no, he will feel that this is something like a snake or rope. Then no one feels that this is an elephant. Hence, you establish communication among these 15 people. Can you say that this is an animal, looks like a tree, a snake, like that? That's the problem. That's the problem. This is the difference between a program accessing entire data, program that is distributed over that. Hence, how do you write the programs for this? That's the point. Hence, people thought that when it is inevitable for me to distribute the big data, hence big data must be distributed. Fine. Hence there is no other way. The moment I distribute, no system is having access to entire data. Therefore, program running in that system can access only part of the data. When there are 10 systems or 15 systems, like now the elephant case, 15 systems processing 15 different parts of the data, how do you, hence 15 systems are processing 15 different parts of the data, and each system has got some knowledge. But that knowledge is only about a part of the data. Let me call that as local knowledge. Now it is seeing only one part of the elephant. It's a local knowledge. Hence 15 systems have got their own respective local knowledge. Now how do you fusion it? How do you combine this entire local knowledge so that you will get the global knowledge, which is equivalent to a single person seeing the entire animal? That is the task. That is the task before you. That's the task before you. Hence, people started thinking that how do you design a new computing so that you can write programs in that computing paradigm which are workable on distributed system. And they thought that they want to invent a new thing, but by that time already MapReduce was introduced for something else, a cloud computing purpose. And immediately they thought this is a suitable computing paradigm. They have taken this. Yes, now let me not again use something. Now what I have to do? Now, first of all, I am distributing the data because big data must be distributed. Okay, I gave one part 1, part 2, like that. I am giving different parts to systems. Each has got its local knowledge 1, local knowledge 2, something, local knowledge 3. How do you combine this local knowledge so that you will get the global knowledge? This is local knowledge. That is what I am expecting global. Okay. Now here there are so many issues involved. One is, since already I have told that there is a underlying network of systems. On that you have loaded Hadoop, a big data technology. Now you are giving this so-called big data and programs. Now first of all, first task is what? Given the big data, it should be distributed. Now who will distribute? Should I, as a user, should I tell the Hadoop, hey Hadoop, distribute my data in this fashion? Hey, I give a matrix. I can suggest, hey Hadoop, distribute row wise. Give first row to one system, second row to another system, and so on. That is one way of doing it. Or I may say first column, second column, third column. Or first 2 rows to one system, second this one, third, fourth row to another system. Something I will tell. Upper triangular part 1, lower triangular. Something, some division I will do. Hence, is it the, now we have to distribute the work. Whether user should tell how to distribute to the Hadoop, or should it be Hadoop, leave it to the Hadoop? Then people thought, how Hadoop will suggest to you? Because without knowing how many systems are there under this and their individual capacities, can you suggest any distribution strategy? Suppose you are in charge for 10 systems. Each system has something. Unless I know that there are 10 systems, each system has this much storage and all, free or allotted for my job. Unless I know, no, I can't suggest you distribute this part to the first system, second system, third system. Means I should know the configuration details of the storage specifications or storage details allotted to my job. Now, what you as a Hadoop, suppose you are a Hadoop, then as a Hadoop you have to inform me about the systems under your control. Then I have to think what is the appropriate strategy that I will tell you, then you will distribute. Is it good? Or really can I think, given the storage details of your systems, really can any human being think the distributed in a better way? Every human being may not think in a better way. There may be one person highly good in distributed thinking, another fellow may not be. Therefore, people thought, let us make Hadoop intelligent enough because it knows what are the limitations and capabilities of the systems under it. And man cannot think, no, therefore they made Hadoop intelligent enough to distribute the data under the systems. Since it knows, oh, this much is available in this system, let me give this many KB, MB something into this. And another system which is already loaded, let me give little portion. No, Hadoop is designed that way. Hadoop is a software, no? Hence, this distributing the data is the Hadoop work. Hence, what user has to do? Give data, that's all. Don't tell how to distribute. Hadoop is intelligent enough. How it is intelligent? Can you make it more intelligent? In what way it is distributing? Yes, there is way you can go into the Hadoop. It is open source. You can look at it. If you want, you can make it a better one. People are taking that Hadoop version to another version. That's going on, fine. If that is your interest, you can go down to that and you can do it. You will be a person researching on that and developing that. That's what different ecosystems, and there are different new versions are coming up in each ecosystem. That's one thing. And some people may not be interested in it. Okay, Hadoop is doing, sir, fine then. I'm happy. Yeah, I need not bother about distributing the data. Then what else? Okay, sir, give the data. Hadoop will take care of how to distribute it. But the Hadoop, once it gives a part to first system, second part to second system, third system, there are n systems. Now each system will ask Hadoop, hey Hadoop, suppose there are 10 people under you, you gave data to 10 people. Now each fellow will ask, hey, what to do with this data? The system is asking Hadoop, what to do with this data? You know pretty well that what it has to generate? Local knowledge 1. But how to get this local knowledge 1 from this part 1? Local knowledge 2 from part 2. And some program has to run here. That program is to be supplied by user. Hence, one program has to be given. This program should be given to the first system, should be given to the second system. Now the question is, will same program work on each of the system? Hadoop initially in MapReduce, that is the style. Once you give a program, the same program will be loaded in each of these systems. Only difference is program is same, parts are different parts of the data. Hence, different local knowledge will be obtained. This program, Hadoop on its own cannot write it. Because what local knowledge has to be obtained as a user, I have to think. Hadoop, you as a Hadoop, you can't do it. Because it is my problem, I know what to get this in the name of local knowledge. Therefore, I have to write a program, give it to you. You as a Hadoop, what you will do? You have already distributed. Distribution is your privilege. Load my program in each of the system, get this local knowledge. This program is called mapper. Hence map logic. Hence map logic, the mapper program you are writing, that is loaded in each of the system. Now this output is generated. Now Hadoop will send this output to another set of systems. Is how it will be, communication will take place between this system and another system, that is Hadoop headache. Someone was talking about a risk, whether any failure will be there, fault tolerance, how communication will be developed, is all Hadoop issues. User need not bother about it. But user has another responsibility is how do you combine this local knowledge? This local knowledge perhaps given to all the systems, I don't know. Something is happening. How to produce global knowledge? Hence, we need another logic, which we call it as reducer, which will combine this local knowledge to generate global knowledge. This is another logic which is required. Hence, now, what are the responsibilities of user, me, when I want my problem to be solved using you? You are a Hadoop, you are in charge of certain number of systems under you. Hence, there are systems under you, there are networked. On top of it, you are working as a Hadoop. I am a user. I have now big data which is to be distributed. I can't load in my system. That's why I brought my data here. Now I will give this data. I started telling how to distribute. Then immediately will say, no, don't tell distribution. Distribution is Hadoop strategy. Fine, I gave data. I am not talking about distribution. We have distributed it. Then afterwards I am waiting. Then they said, no, I have distributed. Now each fellow is asking what to do. You give me some logic. Okay. Now user will give map logic. That is loaded, local knowledge obtained. The local knowledge will reach some stage because Hadoop immediately it will take this local knowledge to another system. That's how it is designed. Why and all? Because it has to be combined. No, because now we understood. Get local knowledge, then combine it. Combining is a different stage, two-stage process. That's why two-stage is there. Second stage also be done by some systems. That's why this local knowledge is taken to another layer of systems. Fine. Here it is combined. But how to combine? Hadoop don't know. The systems don't know. Therefore, again they came back and asked me, hey user, give me another logic. How to combine it? Okay. As a user, I will give reducer logic. This is loaded in each of these systems, and this local knowledge is somehow combined and global. Combined in, who is combining? My program is combining, but who is working? Who is really executing? Executed by these systems with the help of Hadoop. How it has received? It has received the input from the mappers. How the mappers have generated local knowledge because of my program. Who has implemented? With whom help? Hadoop is the situation. Fine. Hence, user has to carry two programs to map and reduce big data, the data which is to be distributed. Take this to the Hadoop, give data, let Hadoop distribute in its own style, don't tell, give map, it will distribute over some systems, and on each of the system this map logic will be run, local knowledge obtained, then give the reduce, local knowledge will go to reducers, reduce logic will be implemented, outcome has come. Do you have clarity now on the whole process? Since whenever you want, you have big data and you have a problem that is working on big data. Now you know what is big data, the data which is beyond the capability of a single system, data big data system. Take that big data and now think of how to solve this big data with the help of just two programs. One is map and reduce. Then you will wonder how, sir, every problem can be solved just with two programs? Yeah, that is the limitation of Hadoop now. It is asking you bring data and give me two programs, then I will implement them. Hence, Hadoop cannot implement. If you give some 5 programs, 6 programs, hey Hadoop, implement these 6 programs. I'm naming the map, reducer, this, that. Suppose you name different names you give. Map, reduce, Rama, Sita, like that. If you name 5 programs, no, it will confuse. No, I don't know. Hadoop is written only to implement 2 programs, map, reduce, only this kind of style. If you have a problem associated with big data, which cannot be solved using MapReduce, then this Hadoop won't help you. Go, don't come to the shop, big data shop, don't come. You go to another shop, there is distributed system fellow. There you give 5 programs. Suppose there is a person who can translate all your high-level programs to low-level program. We can understand the whole linkages among the systems, how to distribution, all he will write. Because you can't write no low-level program. He will write and you can get the problem done. That's why we are not closing the other shop. If the same limitation will be there for other ecosystems, slowly you have to learn ecosystem by ecosystem how to do it. Now this is MapReduce. Okay. Hence this MapReduce computing paradigm is helping this problem solve just with the 2 logics if you can solve. And after all, Hadoop now you can understand, Hadoop cannot take any high-level program, whatever you give and work it on data. Hadoop is intelligent enough to distribute the data. That is one good intelligent way of distributing. Second thing is, if you give only 2 programs called MapReduce, it will implement. And between mapper and reducer, it will establish the communication. And it will push that reducer output, which is global knowledge, onto the user. Since it is taking from the user the big data, it is distributing, implementing in mapper, producing local knowledge, giving to the reducers, producing the global knowledge, pushing to the user. This is what Hadoop is doing. What user responsibility? Take data. If it is big data, go to the Hadoop, but with the 2 programs, mapper and reducer. Any doubt in that? If no, then we'll go to how to write MR programs for certain problems. Then we discuss certain problems. How do we write? Hence, in the whole system, you need not bother about distribution. Hence, the only thing is what we have to master, how to write map logic and reduce logic for this problem, for that problem, like that. Your minds should be trained to write MR programs for various problems. Then only for tomorrow, for your problem also, you can think and write MR computing. Why MR, sir? I don't like this big data and all means days are gone. Now already I told no, Distra won't work. Hence, as long as your data can fit into a system, fine. If you suspect that this generation, okay, sir, next 2-3 years, okay, but later on my data is going to become big for any system, then at that time it will become big data. And suddenly your programs won't work on that day. Hence, even if it is small now, you can distribute them and you can check whether your distributed logic, that is MR, is working or not. Hence, you need not wait till your data becomes big, because on that day suddenly your business will stop. That's why now people are thinking, now any application which is hooked to the web, generating enormous of the amount of data. If you say, I don't like, sir, this databases and all, this big data, MapReduce, distribution, I don't like, I will go to IoT, I will go to cloud. Wherever you go, this MR will be there. And cloud computing, basically what computing? In fact, this MR is introduced, MapReduce is introduced for cloud computing only by Google. These people have used it. Hence, cloud MR computing was prior to this big data technologies. It has been there since cloud computing introduced. Hence, in the cloud computing, the computing paradigm is MapReduce. And you go to IoT, basically their data is distributed. Hence, how to handle the data which is available at disparate sources, so many sources. Do you want to collect entire data at one system and decide and then again give it to the ground level units having sensors? Or do you want to keep them at the respective places and handle in a distributed environment? Here also your big data. Hence now big data is arrived. This big data era is arrived. You can't escape from this. Unless you are, there are so many other areas of computer science where you need not bother about big data. Unless you are a person who is working in those areas, you need not. Yes, now, so perhaps you have heard of blockchain technologies, IoT. These are all basically distributed systems. Okay, fine. Any quick 2 minutes or 1 minute disturbance you can give if you have any doubt? Yeah. Now totally how many participants? Nearly 60 others. Yeah, 60 participants. Yeah, I don't think that because now big data has been there nowadays in the curriculum. Many of you may be familiar with all these things. Anyway, this is a refresher course. If it is the physical platform, I would have asked some of you who knows this and that. I would have started at a higher level, or I would have presented my research where we are writing MR for different this kind. But I don't know what is the level of understanding and your prior touch with big data. I don't know. I am assuming that all are novice to this. Uh, my hello world type of first problem is this. Perhaps many of you who have touch with big data perhaps know, who are new to this may not know. Word count problem. What is this problem? Count the words. Count the words. Where? Words are given in a words are there in a passage. Hence, given a passage, count the words. That's the problem. How big the passage is? 1 page, 10 pages, a big Ramayana. Okay, anything. It has certain number of pages. Okay, take for your example, whatever that, a big textbook. Take Ramayana, and now you have to count the words. Should I count all the words, sir? Which words? Count all the words. All the words means a, the, for, to, everything I have to count. Yeah, count it. Tell me how many distinct words are there in a given book and how many times each word repeated. How many times Rama repeated, how many times Di is repeated, how many times forest is repeated, how many times Sita is repeated, how many times deer is repeated, how many times Lanka is repeated. Yeah. These are all different words. Tell me different words and their frequency. That's the count. How many times they are occurring in that document. So it is too difficult. Okay, I will simplify the version. I will give only 10 words. One word is Rama, Sita, Ravana, and like this. 10 words I will give. 1, 2, 3, 4, like this. 10 words I will give. Now you have to tell me the count for each of these words. What is time? 1:60. Oh, 1. Okay. I have another class at 2. Now, how to do this? Hence, now we give the Ramayana. Now it will distribute it. Suppose 500 pages to each of the system. Now, in this part of 500 pages, I will try ask each system to count how many times and so on. Hence, this system is looking at only 500 pages and has Rama count 97, 64 like this. But this system has not seen the other pages. Now I will create reducers. Reducer 1 for Rama, 1 for Sita, 1 for Ravana and so on. Now Rama count from here it will go. Here also Rama count is there because this Rama perhaps repeated here also in this another 500 pages. This Rama count will go. Hence almost every system is having some Rama count. Sometimes Rama 0 may be there. Maybe that part Rama has not appeared. Still it will go. Now it is this Rama reducer, it will sum up. The summing up and print that. Since it is sum of this 97, 64 and all, then I got it. Similarly, Sita data will go to another system reducer. This is how this being done. And this is how you can write the map logic and reduce logic and you can get the work done. Yeah, unfortunately, we thought that there's a lot of time, a limited amount of time. Without this, we cannot, but require some more hours, but it's not possible anyway. I'm also busy and Atal schedule is already there. Hence, this kind of logics you have to think for each problem. How to get your problem solved with two logics and M and R and get the problem solved. Okay. Yeah. Maybe sometime I'll be free on Friday. Though it is not scheduled, if there are majority of the people interested in listening to MR for certain number of problems, some 2, 3, or 3 or 4 problems, I am ready to spare another 1.5 hour. Though it need not be scheduled, don't disturb the schedule. If someone is interested, majority of the people are interested, then only I am ready to spare my time. Otherwise, fine. See you all maybe in some other. And if the participants are interested to have an FDP on any of the topics of computer science and EC, are welcome to E&ICT Academy by dropping a request, and we are interested to hold this FDP. Utilize this project and fund is available up to March 2020. Thank you. I am abruptly stopping without completing because I have sessions afternoon. We have to start another FDP at VIT Chennai. That is on a different topic. Okay, thank you.
Sir, kindly post your mail ID, sir, so that if there is any need to clarify, they can just send you them. Thank you, sir. Participants, kindly make note of his mail ID or any clarification, you can just drop a letter to him. Thank you, sir.
Right.
Thank you. Thank you, sir.
Yeah.
Thanks for your insight into this most important topic, big data with MapReduce. That I know that it affects all of us have to learn and explore more about big data and enjoy about this topic in the future. Thank you so much, sir.
Right. Thank you.
Thanksgiving is a time of togetherness and gratitude. May I request Miss Maria Eliza, programmer in computer science, to deliver the vote of thanks.
Good afternoon to one and all. It's my pleasure and privilege to thank the speaker of today's Faculty Development Program's second session, Dr. RBV Subramaniam, Professor of Computer Science, Chief Investigator, Electronic and Information Technology Academy, NIT Warangal, for kindly accepting the invitation and sharing his knowledge with us. The session was very enriching. My sincere thanks to you, sir, for providing us a wonderful session this afternoon on map-reduced computing paradigm. I sincerely thank all the participants from various colleges for their active participation in this session. Thank you.
Thank you, ma'am. Dear participants, attendance link is posted in chat box. Kindly do it before the third session begins. Dear participants, attendance link is posted in chat box. Kindly do it before third session begin. Thanks again for joining us in this session. We look forward to your joining us for the third session at 1:50 p.m. We look forward to your joining us for the third session at 1:50 p.m. Thank you. Thank you all.